Let's go check out this no heat situation here. Back room. I think our roof hatch is over here somewhere. All right, a little bit of an obstacle course, but not impossible. All right, so it looks like neither one of our units are heating properly. 64, 62. Let's see what our supply temperature is. Yeah. So this unit says the supply is 92. So maybe we have one unit not working. Maybe this unit's not working. And that unit's trying to heat the entire store by itself. Yeah, that looks to be the case. So this unit, our supply temperature is 50. They're not labeled, so we have one unit working, doing the work of two units. And that unit apparently is not doing the work of anything. I don't see anything tripped, nothing out of place here. Let's get up to the roof. Alright, there's our little blinky light that tells us what's going on. Let's see if we can actually see. Alright, so we got 6 flashes. Come over here. 6 flashes. Induced draft motor fault. Now our induced draft motor is running. I can feel it. There's no pressure switch on this system. What I'm going to do in this case is simply reset it. I'm going to cycle power off, turn it back on, and see what happens. This is actually a Hall effect sensor that's down inside my inducer motor. Now this Hall effect sensor, as far as I understand it, it is just a sensor that when it's exposed to a magnetic field, obviously when this motor's spinning, it generates a magnetic field, and when that Hall effect sensor is exposed to that magnetic field, it produces a signal. I'm not exactly sure what sort of signal it is producing. Well, I just got off the phone with a fine gentleman from Carrier Tech Support, and he gave me some pointers on testing this Hall effect sensor. First test we want to do is make sure there's no call for heat, so I removed my W1 and W2 wires, and then you want to check these outer 2 pins for DC voltage. You want about, I think he said between 6 and 10. I got 10.3, so that's fine. And then the second portion of our test, we're going to plug the Hall effect sensor back in, and then we are going to go black to black and red to white. And then what we want to do is we want to slowly spin the inducer. Very slowly. We spin the inducer, and our DC voltage should change from less than 1 to 8. And it should do that back and forth. Less than 1, 8, less than 1, and 8. Now, I am very carefully going to rotate my inducer motor and also try to hold this together. Alright, I am slowly spinning my inducer motor, and as you can tell, nothing is changing. So that means we have a bad Hall effect sensor. So I am just simply going to replace that entire inducer motor and be done with it. Alright guys, so we are at our working unit. There's the unit over there that we were just working on, the one with the bad Hall effect sensor. So what I'm going to do is I just want to test what tech support told me about this, just to see if it holds true. If I can do this. Careful, there we go. Alright, so you keep an eye on my meter. I'm going to slowly rotate this motor. See, there we go. So it should go, as I spin it slowly, should go less than 1 to 8, less than 1 to 8, less than 1 to 8. See, less than 1, then I'll jump to 8, less than 1, jump to 8. So this one is good. I did check our heat exchanger, no major issues there. Our belt, however, is kind of loose. Not too terrible. Pulley's a little dirty. So what I'm going to do is, I've got a spare right here. This might be in decent condition. This belt's not too terrible though. It's not cracked or broken anywhere. So what I'll probably do is just drop the motor down a little bit, put a little bit of tension on here. No big deal. Alright guys, here's our new inducer motor, our capacitor. Got the zip ties all cut apart. We're going to go ahead and wire it in, bolt it down, and see if she fires up. Now I know I'm probably going to get a little bit of feedback about this. Now, I know you can change, or I assume anyway, I'm going to pull this one off just to play around with it, but I assume you can change this Hall effect sensor all by itself, separate from the inducer motor. But I don't really feel comfortable changing just one part of a component. I guess in my opinion, if it's, even though the motor sounded good, you know, it was spinning at full speed, there was no other issue besides this Hall effect sensor, I just don't feel comfortable changing a part of a component. I'd rather just change the entire component, especially when we're dealing with a large account like this one is, and they don't really appreciate overtime calls, you know, so that's where I stand on that. There's our brand new inducer motor, our brand new capacitor. Come over here, got my belt nice and tight. I'm going to put that panel back on real quick, and then we are going to fire it up and see if she ignites. Because keep in mind, I wasn't able to test any of the ignition components, the sparker, flame sensor, gas valve, any of that, because yeah, obviously the ignition board isn't going to work until that inducer motor actually tells it that it's safe to ignite. So, but real quick before we get to that, I wanted to kind of show you guys this Hall effect sensor. It's much simpler than I thought. It looks like it is. So there's our little Hall effect sensor. So what it looks to be is right inside here. You can see where it's kind of a coated epoxy maybe or something that's in there, but I'm guessing that there's the actual Hall effect sensor is just molded inside of that. So as the motor spins, of course, this little wheel here, I guess, generates a magnetic field, and that's how it senses that the motor is actually going around, and it tells the board that it's okay to ignite. Seems like a fairly simple device, but this is literally the first time I've ever diagnosed one. So it's kind of nice to learn something today. All right. We have ignition. There we are. I got a supply of about 92. Our return air 60, 62. So we got about a 30-degree rise, which is normal. That does it for today. I hope you found this video somewhat somewhat educational or entertaining or something. Anyway, I hope you got something out of it. All right, we'll see you on the next one. Don't forget to hit that like and subscribe button for me. Go ahead and share this video if you know other people who like to watch cool stuff like you do. And yeah, give me a shout out on Facebook or Instagram, whatever. Thanks for watching, guys. I'll see you soon. All right, guys. Here's our project for today. I have this Alto-Shaam oven here, and the screen will not calibrate. I'll show you here in a second. The way you calibrate these is first you turn it off, hold your finger right over the center, and then when you turn it back on, it'll go to that screen, press the field, press this one, press this one, press this one, and it should be calibrated. It's calibrated, but for some reason it doesn't stay calibrated. So after speaking to the manufacturer, what we're going to do is we're going to install a new overlay kit. So we're going to get rid of this entire control panel, and we're going to install the new kit. Now, I brought it out in my work van for a couple reasons. One, because during the process of installing this new overlay kit, we got to cut out some notches behind this glass in the, I guess it's the stainless steel chassis that this interlay mounts to. So I have to cut out some notches, and it's just easier for me to do that out here rather than next to all their food and everything. It's much safer that way. Plus, if I bring it out here, I can make a little video on it, try to help out some of the guys that might be getting into this. I haven't done a whole heck of a lot of these, so I will be referencing the instructions just as any responsible adult should be doing. So we're going to be going through these instructions step by step because this is a somewhat of a sensitive process, I'm told, and everything has to be lined up correctly and done in a specific order, or you could wind up causing more damage than good. So that's what we're going to do. So first things first, I'm going to pull the top off, take these screws out of the top, and then we are going to unmount our power switch and our flash drive connection. Here's a quick view at the top. This power switch right here we're going to disconnect. I already took pictures of all these wires, but I'm also going to make a quick little wiring diagram just in case. There's our control board, and we'll be swapping that out. There's our USB flash drive port. All we got to do is disconnect that and then pop this port out. As you can tell, I got my power switch removed. My USB port has been removed. This one has just got a little twist style nut on there that you remove, and it comes right out. So according to our directions, the next thing we need to do is remove the old overlay, which is basically just this sort of adhesive decal that's on here slash touchscreen interlay. So I'm going to pull that off, and we want to get it off and get as much of this old adhesive off as possible. So because we're going to be putting a new one on there, and it of course has to stick to it. So let's see how this one comes up. Yeah, so I might be getting a razor blade on this, scraping it off. Yeah, see, right down here, somewhere in here is where we're going to be making a new notch. So we'll get that pulled off, get this all cleaned up, and then we'll bring out the template to make our new notch right in there. As you can tell, I got my old overlay off. I got a lot of the adhesive cleaned up. I'm going to go through with my razor blade and see if I can scrape up a little bit more of this adhesive, but it's pretty darn clean. It's clean enough to put a new overlay on there without any sort of issue. So our next step is remove our buzzer and disconnect the 5 cables from our old interface board, which I've already done. Here's our buzzer. We got the 5 cables off here. This is our old interface board. We'll just set that aside. So our next step is to put our template on the front panel. because we need to make a little mark where we're going to have to notch out the part where our ribbon cable is going to go through for our new interface. So right here, this is our template. Obviously I have it held in place with my little hand clamp there. And this is the little notch that we need to mark and cut out. Now, I think what I'm going to do, instead of marking that, I'm just going to leave this template on there. And then I'm going to just cut it with the template in place, because that seems like it's going to be easier for me anyway. So, let me put the phone down and I will handle that. Now right here is my new interface board. I got it mounted up to its new mounts, I suppose. So that's all ready to go. Now, next step in our instructions is to put on our new protective covering, new overlay, and they stress the importance of properly aligning everything. So I have it just kind of dry fitted on there. And what I think I'm going to do is leave it on there and then pull off like one side of the adhesive, let that stick, and then I'll peel this up and pull off the other side just to make sure it stays in proper alignment. So I'm going to need 2 hands for that though, guys, so I'm going to have to put this camera down, and since I'm filming outside in my van, there's really no good place to put my camera to kind of show you guys this step, but I'm going to try. Take this adhesive backing off here so I can try to get it on there, but man, this stuff is difficult. This is what I'm talking about right here. I'm just going to pull half of it off here so I can better align it without having to go with full sticker right away. All right, new overlay is on here. It's looking good. Now we just need to get a new interface board connected, and we'll power it up, and then we'll just have to update the software. All right, guys. My rocker switch, my power switch is back in place. Interface board is in and on. There's our USB. I am currently going through the software updating process. My USB right there. Now, when you do go through and complete one of these repairs and you have to update the software, it's very important, apparently, according to tech support, that you format that flash drive before you download the update onto it. And all they did for me is they just emailed me the update and I just downloaded it when I was at home. So it should take another few minutes, and then what we'll do is we'll power it back off and just make sure that the screen is calibrated. Then we'll roll it back inside, set it in place, and get out of here. Alright guys, we are all set here. As you can tell by the screen, it's up and running. It's been recalibrated, software has been updated. So I'm gonna throw this thing back on my cart, wheel it inside, and let them get back to doing whatever they do with it. Alright, so go ahead and hit that like and subscribe button for me, guys, and I will see you on the next one. Alright. Hey, what's up YouTube? So today is Saturday. It's about 8:45 in the morning. I'm on call and I'm heading to my very first service call. So anyway, stick around guys. I'll bring you along for the ride, show you what I can, and see if we can't learn something together today, alright? There's our two thermostats. This one, I believe, is connected to the system that heats the front of the store. This one is connected to the system at the back of the store. The problem is both thermostats are back here at the back of the store, and neither one of these have a sensor hooked up to the zone that they control. So what's happening is the systems are overheating the spaces and they're overcompensating just so the heat will eventually reach these thermostats and then shut off. So what we need to do is go back to the energy management company that just recently took over this location, and we need to have them give us some zone sensors that we can connect to their system. Here's one of our problematic issues, is the grooming area. There should be a zone sensor in there. I think that's what I'm going to recommend. They put a zone sensor in there. And then over here, I think we'll try to put a zone sensor maybe right where that pole is going up in the ceiling. I don't want to put it on an exterior wall, so that would probably give me a good sense of a good average temperature of the front of the store. Right now what I'm going to do, I'm going to get up on the roof and just inspect our rooftop units, make sure heat exchangers are good, and maybe get an idea of what other kind of control system they have for this location. So anyway, here's our American Standard train looking unit, right? And I don't see anything out of the ordinary. I'm still going to pull this middle panel off, check my belt, pull the opposite panel off, check the heat exchanger. This unit doesn't look that old, so I probably won't find any cracks in it, but just to make sure we cover all our bases, we're going to go for that big picture diagnosis. Real quick tech tip, I'm sure a lot of you guys know this, but these train labels, they wash out in the sun, you know, in about 17 minutes after it's installed. But if you go over here to our main control panel, take that off and flip it around, there's a secondary data tag that's on there. So again, I'm sure a majority of you guys know that. Here's our other unit, R2 number 2. Judging by the size of this one, I'm assuming this is what controls the heat and cooling for the showroom part of the store. And we're going to do the same thing. Double check that belt, that heat exchanger. Even though this unit's fairly new, I'm sure I won't find any issues, but we're going to do that just to be sure. Air filters look okay. Belt looks pretty good. I don't feel any major wear marks on this pulley, so that doesn't concern me whatsoever. Our heat exchanger doesn't look the healthiest though. Given the overall age of the unit, I was kind of expecting the heat exchanger to look a little bit better. So I think what I might do is double check my incoming gas pressure just to make sure the unit's not overfiring, or make sure, you know, we don't have high gas pressure causing the unit to overfire. But I don't see any actual cracks. There's some spots that look unhealthy, but yeah, I kind of poked them with my screwdriver. I didn't get any actual separation, any holes or anything like that. So I'm not going to lock it out, red tag it, shut it down, all that stuff, but I am going to quote to replace this heat exchanger. And then also what I'm going to do is we'll do a quick CO2 test in the building. I'll just walk around with my CO2 detector, see if I get any hits anywhere. All right, I got my gas on, manometer is hooked up, and right now we are sitting at about 7 inches of water column. Let's fire it up and see what happens. That was terrifying. Yeah, we're still sitting at about 7 inches of water column. Shut this off. Turn our gas back off real quick. Check out some numbers on this valve just to make sure. Regulator 3.3 inches of water column. So, according to my calculations, we have a little bit too much gas pressure going in there, so I believe we are overfiring. We are at our second rooftop unit here. There's our heat exchanger. Not as bad as the first one. Again, given the age of the unit, I did expect it to look better. So let's go over here to our gas valve. Now, the way this gas valve is designed, there's our outlet pressure testing port, and our inlet pressure testing port is right back here, right next to this elbow, where we really don't have any logical access to. I could access it, but I'd have to take the gas line off and then move things around and sort of reconnect it so I can actually get in there, remove that little Allen key, that little plug, and get my manometer on there. But that's not realistic in this situation. So what I'm going to do is I'm going to pull this plug out, just check our outgoing gas pressure, assuming our gas valve works, which again, assuming it works because our store is overheating due to trying to compensate for those thermostats. So assuming our gas valve works, I'm just going to test our pressure right there and see if it's comparable to that unit, which was measuring about 7 water column inches. While I'm waiting for my heat to come on, you'll notice on this transformer, we are on the 230 volt tap. But if we measure the voltage going to it, we're closer to 208. We're at 212. So that'll make our outgoing voltage 23 volts. And a lot of these control boards want 24 to 26 volts. So we'll have to swap that tap around and just put on the 208 tap. I'll double check that one because I didn't check it initially. As you can tell, I got a mess of jumpers on there. We're going to kick it into stage 2 real quick. Double check my voltage here. 212. I'm on the 208 tap now. And we're at 26 volts. Much better. So whoever installed this apparently didn't commission it properly or just overlooked that. It happens. So let's wait for our stage 2 to kick on and see what kind of gas pressure we got. Well, this unit doesn't seem to have that same problem that the unit over there has. If anything, we're a little bit lower under gas pressure, but according to my calculations, we are in stage 2 heat. So I'm not as concerned about this unit. I'm back at this first unit, and our pressure isn't as high as it originally was. Remember, we were up around 7, and now we are closer to the range that we wanted to, the acceptable range of approximately 3.5. So I'm just going to assume that we have a regulator issue or a gas pressure issue coming into the building. And on this particular building, I don't have access to the regulators, no way to check them. So I'm going to have to turn that over to the landlord. But just thought I'd point that out real quick. All right, guys. I'm going to call myself out on something real quick. Now that second test we did, I was actually on this port right here, our outgoing gas port, and I was measuring close 3.8, maybe 4 inches of water column. And our first test was back here where my Allen key is, and we were measuring closer to 7, sometimes 8, which I assumed was too high. And based on the condition of the heat exchanger and the way the flame looked, in my opinion, we were overfiring. But our outgoing gas pressure to the burner actually wasn't that bad. It was, like I said, 3.8, maybe 4. So I busted out the manual just to double check a couple things, just to see what our maximum supply gas pressure can be. And it says right here that the maximum gas supply is 14 inches of water column. And we were just about half of that, 7, almost 8. And our minimum manifold gas pressure is 3.3. So according to this, I think we're fine. I guess we don't have a incoming gas pressure issue like I assumed. That just makes me wonder now why my heat exchanger looks like that. I guess chalk it up to poor design, maybe. Possibly even airflow, of course. I don't have access to the ceiling to look at all the ductwork right now, but that'll have to be something I double check when we come back and run a new zone sensor. We'll have to double check the ductwork, see if I can get in there, maybe do a little bit of a static test on it. But our heat exchanger looks like garbage. I'm still going to quote for that. We don't have a high gas pressure situation like I thought we did. So we're going to leave it at that. Okay, let me see what we got going on today. Freezer, -3. But our problem is all this moisture on our freezer ceiling. It's all that frost and everything else. Now this is a brand new build. It's a brand new location, and their walk-in cooler actually has a roof leak and water's dripping down into the cooler itself and forming puddles. So part of me thinks that between the actual rubber roof membrane and the top of this walk-in cooler box, there might be water sitting up there due to a roof leak. Most of the time when I see issues like this, it's usually a defrost issue where it's defrosting too much, staying in defrost too long so the box actually warms up and condensation forms on the ceiling. Or the fan delay, I guess, could also cause sort of an issue. But usually if there's a fan delay issue, I'll see a lot more of these little droplets in front of the fan, because our compressor would kick on and our fans would kick on almost immediately, and there'd be hardly any drip time for that evaporator coil. And so all that remaining condensation that was melted off during the defrost cycle would just get shot out the front by the evaporator fans, and most of it would be stuck up on the ceiling there. So it looks like we have a good amount of defrosts. 3 45-minute defrosts. So I'm going to watch that defrost clock for one, make sure it is rotating, and then what I think I'm going to do is I'm going to put it in manual defrost and just watch my X terminal, just to make sure my early termination switch, my defrost termination switch, kicks in and shuts it down. Alright, so I'm hooked up to my X terminal, and we're going to put this thing in defrost. Sounds like one of our fan blades is hitting a little bit of ice. Alright, heaters are on. So now what should happen when that defrost termination switch warms up and it closes, I should have 0 volts going across it from X to N to my neutral. So that's what we're waiting for. It might take a little while, guys, so I'm going to shut the camera off, step outside this box real quick and warm up. I was hoping to get up above this cooler and take a peek at the top of this box, but looks like we don't have access to that. All right, here, guys, is our walk-in cooler. We have standing water in here, and the manager says that whenever it rains, they get water just kind of seeping out of the walls. He never said there was any really dripping down from the roof, but if you'll notice, you can kind of notice right over here around these plugs, there's a little bit of watermark. So he said it'll drip down through there, kind of seep through the panels. So I'm pretty sure we have a roof leak or some sort of leak. So what I'm going to do is I'm going to go back to the freezer. I'm going to double check these plugs and see if our insulated panels are just full of moisture. It's got moisture in there, frozen moisture. That one, not as bad. Hardly anything in that one. Yeah, I got some. That one's all froze up. Huh. Well, to be honest, I've never really seen that problem before. So I just wanted to share this real quick. So I found this, and it's sort of a weird ice pattern because it's not really attached to the coil. It almost looks like it was formed from, I guess, water sitting in top of this coil, like right above the fan. And it would just freeze and slowly drip down to form this weird iceberg. Yeah, it's a weird frost pattern. Yeah, nothing on that side. Just a little bit in the grill guard. Finger guard, if you will. Yeah, the rest of the coil is clear. The back side, front side. There's all this condensation. Yeah, see, it's even up there underneath this, whatever you call this panel, between the top of this evaporator coil and the actual box. So we're still in defrost. The box temperature rose to about 7 degrees, and apparently our defrost termination switch isn't warm enough, so nothing has changed yet. I think I'm going to pull the panel off that side just to double check everything. Alright guys, at first glance I don't see anything out of the ordinary. We got our heaters in the bottom of the pan. 2 heaters going across the back. Right here is our high limit. Back here we got our defrost termination fan delay. Looks like we have a relay right there. Not real sure what that relay does yet. Maybe it's a relay to help engage our heaters. That would make sense. So you can tell our ceiling is starting to thaw as well. Alright, if you'll notice right there, it looks like our defrost termination switch has kicked in, and we are now out of defrost. So our issue isn't the unit staying in defrost too long. And our fans are not on yet, which is good because I have that fan blade off. So I'm going to have to go shut this down real quick. So since that's not our problem, we're going to have to take a look on the roof, see if we have some moisture penetrating somewhere, which I believe is the case. I'm sure some of you guys out there have experienced this before. Let me know what you think. Share some stories. Alright guys, I'm just wrapping up here real quick. Tech tip of the day. Before you put these finger guards back on, make sure you put the fan blade back on. I was on the phone when I was putting these back on, and apparently my left side of my brain must not have been working because I put the grill guard on without actually putting the fan blade on. So don't do that, because it's not going to move any air if you don't put a fan blade on. Alright, let me set this down and get back to it. Here we are on top of this location. Just kind of noticing our line set here. I'm just up here looking for any obvious leaks, any cuts in the rubber membrane. I don't know much about roofing, but I feel like I should have done a little bit better job with this. Maybe put some curb or some sort of a flashing material right there around that. Right over there, that is our walk-in cooler. You check out that amazing line set. That line set looks like garbage. The other thing too is this line set isn't actually not actually fastened down to any of these rubber blocks, which doesn't make any sense. You know, sometimes we get a lot of wind up here in Michigan, and I mean, that thing will go bouncing around. You're gonna get a crack or something in there eventually. I'm not gonna pretend like I know all the codes or anything, but that doesn't seem like it's up to code. Right there too. Eventually that's just gonna cut right through and short out. I know this is, what is this, SOJ cord maybe, sun resistant, oil resistant, but I don't think it's rated to be outside. I could be wrong. Again, I'm not gonna be one of those guys who pretends to know all the codes, because I don't. Real quick before I get off the roof, I just noticed this. So right now I'm standing on top of our walk-in cooler. If you remember, over in the corner we had standing water inside the walk-in cooler. So if you look at right here, we just got some silicone that apparently was put there to fix some sort of leak at some point in time. So I'm not a roofer. I don't know anything about fixing these. But I assume just putting a bead of caulk around there isn't really going to fix the problem. You need to actually take that off, clean the rubber, flash it properly, put a new piece of rubber across it, I guess. So that's probably why we have standing water in that cooler. Alright guys, so we're back down inside this walk-in freezer. I wanted to point something out real quick here. So right there, if you'll notice that seam. That seam is opened up pretty wide, especially when you compare it to some of these other seams. So, based on our frost pattern, I believe we just have warm air infiltrating this box. Most likely from this seam. There was a seam over here that looked kind of wide as well. Up there it's kind of hard to see, but there's a little bit of an opening in that back wall right there. And then kind of behind this right here, you can see that it's not a real tight fit in between there. Now, the problem is, how do we address this? How do we come up with a solution? My only idea is that we would have to remove everything out of this freezer, shut it down, let it thaw, let the walls thaw, because the walls are full of moisture and they're frozen. Bring in dehumidifiers, heaters, warm it up, try to get as much moisture out of there as possible. Get the roof leak fixed for the walk-in cooler, and I believe there's a leak up there somewhere that's also bringing in a little bit of moisture up above this. But I was talking to my buddy Chris Stevens, and he had mentioned, you know, he said obviously if there was a leak, I would probably have a giant icicle hanging down from the ceiling to the floor, which makes sense. But there's quite a bit of moisture in here. All right, guys, let's talk about what you just saw there. So, I don't think I mentioned this in the video, but that was actually a warranty call from Hvac. And obviously, because it was such a new build, the box and equipment was still under warranty. So I went back to the manufacturer, Hvac, and made some suggestions to them. And one thing I also tried, I didn't get this on film, but I did try to tighten the interlocking, I guess they're locking bars, locking arms, whatever that connect those ceiling panels together. I just took a 5/16 Allen wrench, jammed it up in there, and tried to get those locking arms to close a little bit tighter, to get that seam to close a little bit tighter, but it really didn't work. The ceiling panels don't want to move. And since I don't see any other place that warm air is infiltrating the box, so I went back to the manufacturer and explained that I believe warm air is infiltrating through the seams in the ceiling panel, possibly, maybe a little bit of moisture from a roof leak as well. I'm not 100% sure because I'm not a roofer. So I put in a bid to go back, shut the freezer down, let it thaw for a day or two, and then we'll run some silver caulk through those seams and get everything sealed up nice and tight. And then we'll let the box run for a couple days, and then we'll reevaluate it, see if our problem has been solved, or see if we still have frost on the ceiling, see if we still have some sort of warm air infiltrating, or whatever the case may be at the time. But for now, that's where it stands. All right, guys, so hope you like this video. Hit that like and subscribe button for me, and if there's a follow-up, I'll let you know. If not, this will be the end of it. All right, we'll see you on the next one. Good morning, YouTube. How's everybody doing out there? I hope you guys are doing great. What we have going on today is we are going to see a new customer today. It is a fast food chain. They are the home of the meats, apparently. You can figure out who that is. And they are complaining because the dining room is really, really cold. Apparently the heater has stopped working. So we're going to head over there and see what they have going on. And I'm going to try to bring you guys along for the ride and show you whatever I can. Hopefully it's something fun. All right, dining room's 57 degrees. So this is an energy management controlled location. So we're going to have to get up on the roof and see what's going on up there before I call them. And what I'll do is just bypass this thermostat, jump it out at the roof. All right, let's go. All right, guys, here is our unit that is not working. Our inducer is blowing cold air, actually. It's not blowing hot air at all, so we're probably off on, let's have some fun. Let's guess what's wrong with it before I open it up and try to figure out what's actually wrong with it. See if our inducer is blowing. It's probably off on a failed ignition or a limit switch. I'm going to guess limit switch. I'm going to say, oh, let's say that belt's broken inside. Just for the heck of it. If our belt's broken or our motor's not running, it's going to turn on a heat mode and then cycle off on a high limit. Hey, look at that. Yeah, that's a good guess. I pulled off this busted belt here. I was looking at our motor pulley, and I don't know how well you can see this on camera, but right inside this pulley here, we got a pretty good little dip going. It's not terrible. I'm gonna call around and see if anybody has one of these in stock locally. I can just pick it up and swap it out real quick. If not, I'll just have to order one and come back. But always want to look at that. The pulley back there, our drive pulley, our blower pulley rather, looks pretty good. Now, we also, before we go any further, want to check our heat exchanger. I already had the panel off and I already gave it a good look before I turned the camera on. Everything looks fine in there. I don't see any rust spots, any hairline cracks, any suspicious issues whatsoever. So I was just about to head downstairs and start searching for a belt when I realized I should at least check to make sure the unit actually fires up in heat mode before I do anything else. So I cycled power to it, I turned it back on, and I got 4 flashes on my ignition module, or my ignition control board. If we go over here, that means our limit switch is open. Limit switch right back here. It's a resettable limit switch right on the blower housing. So if we go across here, I don't have any continuity. So let's see if we can reset this guy. And it clicked, so we should have continuity now. Yep, there we go. Well, I couldn't find anybody locally that had this motor pulley. So I'm gonna have to order that and quote and come back to install that. But I was able to get a new belt as well as a spare to put in here. So next time they have this issue, whoever fixes it can just pop the spare on there like I could have done today if they would have had a spare inside here. So anyway, since I have to quote to replace that motor pulley, I'm also going to recommend they replace this, what's this called, a high limit or a plenum liniment, I think it's called. And that's only based on its condition. The spade ends of it are just, they're just rusted out. So as well as that limit, I'm also gonna replace this limit back here because it tripped. I'm assuming it probably only tripped once, but you never know. It looks kind of beat up. Terminals are rusted out. It's all covered in gunk and whatnot. So we're gonna replace that as well as a preventative measure. I'm gonna fasten this cover down before I go and clean up some of this wiring, zip tie it all like it should have been. See, that's my issue. For some reason, it shuts itself off after a few minutes. I'm not exactly sure why. Alright guys, so the problem I'm running into is the energy management company that I used to have in place for this site is no longer being utilized. Instead, it's going through a different third party. Nobody really knows who that third party is. So I am limited in my controls with this this thermostat. I've gone through a couple different programmings, checked the install guide. I can't find anything definitive as to why the thermostat will just turn itself off after a minute or two. So I'm currently waiting on some additional information to see if I can find whoever controls this site. And what I'm about to do is I'm about to just drop a thermostat down the return, sort of an emergency repair, because I can't reach anybody from their corporate office or from their energy management company who can tell me if they do control this location. I'm sure somebody does control this location, I just don't know who. And nobody at this location knows, and nobody at the corporate office knows who controls this location. This is the, sometimes this is the downside of doing commercials. You have to try to go through 15 different people just to see who actually controls the thermostat you're standing in front of. But it is what it is, guys. So, like I said, what I'm gonna do is drop that down the return. I have it set to heat at 74. My fan is set to continuous. No big deal. I've done this a few different times, and what we'll have to do is, as soon as they can tell me who controls this thermostat or who controls the energy management system for this location, then we can come back and properly program their thermostat and set it up the way it should be set up. Because what I assume happened, which I cannot confirm again because I can't reach anybody, but what I assume happened is when they put this work order in, whoever controls the energy management system here, they just went into their system and they shut that thermostat off. That's normally what they do at a lot of these large franchise locations. And when they do that, you sort of get the same symptoms that I showed you guys, where the thermostat just will revert to off mode. Anyway, so I got that set. Let me turn this on. I just want to make sure it does heat. There we go, it just fired up. Let's take this and throw it down the vent before they start getting too cold with all this outside air I'm pulling in. All right, I'm gonna turn this off so I don't fall in there. Let's see. Temperature is rising, 95. It's gonna keep on going. That's all for today, guys. I'm gonna do a follow-up video on this as soon as I get approval to come back and remove my temporary stat and I guess talk to whoever controls this site. All right, so today we're hanging out with this 20-ton York unit. I believe it's about 20 years old. Let's double check the data tag here. Blah, 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 20-ton. Looks like it's 01, so roughly 20 years old. Now, I was originally out here to quote a replacement. I'm not sure what happened, but the customer decided to just go ahead and start repairing it. When we quote units, we don't charge for the quoting process. So when I was here originally to quote the unit, I wasn't allocated the time and money needed to actually diagnose the unit. So when they decided to just have us come back and start the repairing process, I explained that it may be a multi-layered process because I don't know what's wrong with it yet. As you can tell, our disconnect is off. So I said I'll go back there as long as I have a few components, just a handful of random stuff. When I was here originally, you'll see some boxes laying down there. When I was here originally, I did open up the panels, look around, do sort of a visual inspection, and I did find a lot of new components have been thrown at it. So I don't know really what I'm getting into, but I just wanted to have a couple, like a flame rod, sparker, all that stuff, just to have on hand. All right, let's get a little bit of a closer look at what we're dealing with here. Our main control section, nothing too crazy. Ice cube relay just kind of flopping around. That's not real cool. We'll have to put a zip screw in there and hold it down. Notice right here, I really don't like when people do that. If you for whatever reason need to cut a wire like that, just put a piece of tape over it, trim it back up or something. I mean, again, they do make jumpers that you can just magnetically click onto those terminals right there. Or what I've done before is I'll just trim a little bit of the wire right up next to the terminal, just so it doesn't look like garbage like this. Let's see, relays over there look good. And again, guys, I did this when I was initially here, just sort of visually inspected everything. When I was here originally, I did test it for any shorted out components, and I didn't find any. There's our freeze stat right there. We got some fuses back there. That's all right. Ignition control module. What do we got here? Some sort of control board. Now, this is where the magic happens right here. Say we got an old sequencer. I think it's a sequencer anyway. Insulation is shot. Now this unit did have a new exchanger installed right here, 12.4 of 18, and I did verify last time I was here the heat exchanger does look fine in this unit, so I'm not worried about that at all. That wiring is a little bit of a rat's nest, just a little bit. Another thing, look at this. Why would you not just put that wiring back in the proper location? I mean, did you not have 4 seconds to spare? You know what I mean? Don't take the path of least resistance through your day, Looks like our frame was modified to accommodate this new gas valve, so that gas valve's not original. I'm guessing either the manufacturer no longer makes that gas valve, or whoever was here just slapped a universal one in there. We'll have to see if that works. You see our sparker right there. It's not supposed to flop around like that. That looks decent, nothing crazy. Belt's good, nice and tight. No abnormal wear on the pulley. Keyway looks good. Bearing looks good. I mean, there's no play in it. Right here, this is where our freestat apparently must have failed, so they just cut it and bypassed it. Alright guys, I didn't get any footage of this, but I wasn't able to actually get that flame sensor reattached from where I'm at. I just can't get my arms in there. So what I've done is I labeled all of these wires. See right there, my little orange dot system. I labeled all the wires, took pictures, and I'm just going to pull this whole burner assembly out, because it looks like once I break this union here, this whole thing will just come right out, and then I can, you know, reattach it and slide it back in there and kind of see what's going on. By the way, I already loosened that. That wasn't on there hand tight. Yeah, I was hoping that I'd get tangled up in some wires. I was really hoping for that. There we are. Now, since I have this burner assembly out and I do have new sparkers and flame rods, I am going to replace them, not knowing if they're good or bad. Chances are they're good, because these are usually pretty, I mean, these are pretty tough. Unless the ceramic breaks, there's really not a problem with the flame rods. Usually with these, I mean, they do get old, I guess. They can kind of get dirty, but for the most part, I don't replace a lot of these, honestly. I find they're pretty tough. But since I don't want to have to put this thing back in there and find out that something's wrong, what I'm going to do is I'm going to replace the flame rods, the sparkers, again, since I have new ones. And then I'm also going to go through and just take a wire brush and clean up the surface of this pilot tube, because that is what the sparker sparks against. So on these systems, guys, make sure you put the spark igniter in the right position. I just about put my spark igniter up here before I realized up here is the end of the pilot. Down here is the beginning of the pilot tube. So obviously I want it to spark over here first, because if I don't, I'm going to have gas spewing out of this pilot, building up behind here until it finally hits the spark igniter, which would have been over here. So I don't want to make an explosion. Not today, anyway. All right, real quick, guys. This might be kind of hard to see, but if you looked right here, so this right here is our spark igniter. And as I was installing this, I accidentally lined it up with the wrong hole. So what somebody did at some point in time is they just used probably a self-tapper and they made a second hole underneath of this. Now, what that did, and I don't know how it really affected the operation of the unit, but essentially what that did is that took this spark igniter and it just made it point at a slight angle. Chances are it still worked fine, but you know, obviously it wasn't designed that way, so you might get a little bit of intermittent spark issues. If it's too far off kilter, it might not be close enough to this pilot tube to actually make a spark. All right guys, so my OCD is sort of getting to me since I've been cleaning up a lot of left behind trash in this unit. So what I'm gonna do is I'm gonna vacuum out this burner section, just get all the dust and crap out of there, because all of this dust and crap is gonna end up on my flame rod, on my sparker. It's gonna get into the burners, and I just don't want that to happen. So we're gonna vacuum it out real quick. All right, much better. Let's get these out of the way. We'll slide this burner back in place and see what happens. As you can tell, the burner assembly's back in place. I'm pretty sure I have it wired up correctly. Got my Molex connectors reinstalled, all my wiring cleaned up, zip tied, ready to go. I don't see anything that needs to be addressed as of this moment. So let's fire it up, see if we have a call for heat, and see what it does. Inducer's on. See if we can hear some sparking. And we have ignition on one of the circuits. I still hear sparking on what I believe is the second circuit. So this circuit, definitely hot, definitely ignition. This one, nothing. Real quick, I just want to double check to make sure I do have a W2 call. I believe black is my common, still 25 volts. So we do have a call for W2. So what I'm gonna do first, guys, I'm gonna put the camera down and just double check all my wiring. Make sure it wasn't something silly that I missed. All right, so let me do that real quick. Before I forget, guys, second tech tip of the day, something that AC Service Tech, formerly your mama, had pointed out to me online. What I've done before on these when I'm checking heat or anything, what I'll do normally is I'll just kick my disconnect off in the middle of a heat cycle, which is a big no-no. And mostly that is because once you do that, your heat exchanger is still hot and there's no air moving over it. So you're probably going to trip your high limit. So what you want to do instead is just find a way to disconnect or stop the heating signal, whether that's taking a jumper wire and initiating a call for heat so you can easily disconnect your jumper wire and stop the unit from heating. But whatever you do, you want to keep that blower running and you want to stop the unit from igniting. You could even go over to the gas valve and shut the gas valves off if you want, or shut the gas off, whatever you want to do. But as long as you stop it from heating and keep the blower going, so you keep air going across that heat exchanger so nothing happens. Let's do a quick recap, guys. So here's what I did. I double checked all my wiring going to my ice cube relays, W1, W2, my inducer, all of that looks fine. And then I double checked all the wiring going into my rollout switch right back there, which I originally called a sequencer. It is not a sequencer, of course, just kind of looks like one. I double checked all the wiring going to my inducer, or my ignition modules down to my gas valves. That's all correct. And then I chased voltage from my ice cube relays over to my rollout switch, over to my ignition modules, and down to the gas valves. As far as I can tell, I have proper voltages coming out of the ignition modules down to the gas valves, but just to be 100% sure, I flip-flopped the ignition modules, and the problem still stayed with this burner section, which I believe is number 2. That one down there is number 1. Down there, that one's fired up every single time. That one I have no issue with. It's just this one. So what I'm getting out of this one is just a faint sparking nonstop. So I believe my pilot isn't getting any gas. So I pulled off the pilot adjustment screw, and inside the little tiny screw that's in there looks pretty beat up, like it's been adjusted like a million times. This pilot tube looks like trash. It's kind of kinked over a little bit. Not bad. Doesn't seem like it's leaking. So what I'm going to do is I'm going to take the pilot off and use my manometer down there, and just to see if I have gas pressure, see if it's actually opening or not. I don't smell any gas when it's trying to ignite, so I don't really know what to make of that. And while I have it off, I'm also going to blow that pilot out with some nitrogen, assuming that I do have actual gas pressure coming out of there. Let's pull this off, hook up the manometer, and see what we got. All right, let's turn it on and see what happens. Inducer is on. The door blower should be on in just a moment. So if you'll notice right there, we do have gas coming out of the pilot tube. As you can tell, we had pressure coming out of our pilot tube. So what I'm going to do now is go get my nitrogen, blow out that pilot tube, reattach it, and see if we can get that pilot tube to ignite, or that pilot light to ignite. I didn't feel like dragging my nitrogen tank up here, so I just got my gallo gun, my drain shot gun, whatever you want to call it. So what you're looking at is this rollout switch. Now, I didn't pay close enough attention initially, but I'm pretty sure it's basically bypassed. So what we have over here, this black wire and this red wire are coming from our control section. This is our 24 volts coming off of either one of our ice cube relays, R1 or W1 and W2 essentially. And so what happens, so we have 24 volts coming in both sides of this, which is confusing. And then these two top terminals are connected. The bottom two are connected. So it's basically, top one is, we'll say, rollout switch number 1. Bottom one is rollout switch number 2. So what happens in this situation is 24 volts comes in on my black and red wire, goes through this top bimetal, give you a better look there, and then it comes over to this side where 24 volts goes out to this green wire, which is connected to my rollout switch on ignition module number 1, and then this other side is, of course, just jumper down to the bottom. And this jumper takes 24 volts over to my TH terminal on number 1 ignition, and then it goes through here, and then it goes over to my TH control on number 2. So, I mean, it's still going to do the same thing if this unit goes into rollout, you know, exchanger cracks and flames start shooting out the front. It is still going to break the 24 volts. but it's just not wired up properly. This black wire needs to be down on this bottom terminal, so I'm basically on both separate sections. I don't really need this jumper wire. I don't know why that's there. So let me show you what I'm talking about on the schematic. Luckily we have a somewhat easy to read schematic. So here's our number, or W2 rollout switch number 2. Let's see, 24 volts. I'll double check that. It looks like it's coming off of our centrifugal switch. IR number 2. Right here is my rollout switch. So I have 160, which is my black, which comes from the relay, and it goes to one side. So as you can tell, on one side of my rollout switch should be black 460, not 160, 460, and one side of that will go up to my TH terminal. The other side goes through the bimetal over to rollout switch number 1 on the ignition module. No, we can leave that there, and that's my rollout switch. This one, need to get that off there. Alright guys, so I think I got it. Let me double check before I start talking. Alright, so W1 incoming power comes down in this line. This other red wire, which is tied into it, goes over to our TH on ignition module number 1. Then it comes through this bimetal, assuming that it's not on fire, and then it goes over to our rollout switch number 1. And then on this back side here, black, which is our W2, comes in, and there's a jumper right here, so it goes over to this white wire, which is connected to TH terminal on our number 2 ignition module. Of course, assuming that this is closed, it will go through here, and then it will go over to our rollout switch on number 2. Let's fire it up to see if anything crazy happens. Alright, ignition on unit circuit number 1. Circuit number 2 is still dead. So I have 25 volts on my rollout switch. On my ignition module. So I do have proper power going into my ignition module, and I can hear it sparking. So right now I'm just going to go back to assuming that there's an issue with that gas valve. Most likely an issue with the gas pressure coming out of that pilot orifice. I'm going to do a little bit of research and see if I can figure out what the gas pressure coming out of that pilot tube or out of the pilot side of the gas valve should be, because I honestly have no idea. And then I might just go ahead and replace that gas valve just because the pilot gas pressure has been adjusted so many times, and also that pilot gas pressure too, or that pilot tube I don't like. This pilot tube, I just don't like this brass fitting. I don't like this kink right here. It's just a place it could leak eventually, or crack and break off and cause all sorts of fun problems. Anyway, I'm gonna wrap it up and get out of here. submit a quote, get some parts, and we'll see you guys when I return, all right? Hey, what's up, YouTube? So welcome to part number 2 of this no heat situation we have going on with this 20-ton York unit behind me. Now, it's been about 2 weeks since part number 1, and I am here today with a gas valve, a little bit of pilot tubing, and a couple other components. So what we're going to do today is I'm going to remove the burner assembly. I'm going to put a new gas valve on stage number 1, circuit number 1, whatever you want to call it. And then we're going to put a new pilot tube on there, a new runner, which is actually, I guess that's probably called the pilot tube. But there's a runner that actually has that actually makes the fire, that actually makes the ignition process start. And then there's a pilot tube that goes from the gas valve to that runner. You'll see what I'm talking about. I'm not crazy. So we're going to put that on there. But one of the things I'm going to do is, while I have the burner assembly out, I'm going to plug all the wiring back in just so I can watch the spark and make sure it's sparking in the correct spot. Because if you remember, last time we were here, we weren't getting any ignition. And the way the burner assembly is set up, I can't see the actual spark igniter to see where the spark is landing, to make sure it's not grounding out, to make sure it's actually sparking across the pilot runner where we actually have gas. So that's the plan, guys. Let me turn this camera off, pull some panels apart, and I'll bring it back in just a minute, all right? You know what? You guys are probably getting bored of watching me do this again, because you already seen me pull this burner assembly out in part 1. So I'm going to pull this out and bring you back in just a minute when I actually do some fun testing, all right? So hang in there. All right, guys. As you can tell, our burner assembly is removed. And what we're going to be doing is I'm going to break this union right here to replace this gas valve. Also, I'm going to replace this pilot tubing. And I'm going to put a new runner on here. This new orifice is going to be replaced. This is the runner right here that I was talking about, this one right here. And I'm only replacing that, not because it's bad that I can tell, but I'm replacing with a brand new one just to make sure that I do get proper ignition, so that when my spark is initiated, it's actually making contact with this runner. That's really all. It's just sort of a preventative maintenance thing. Of course it doesn't want to come out on its own. Guess you don't really call that a nut, do you? There's our 20-year-old runner. There's our new one. All right, let's get this gas valve out of here. I think, in my opinion, the best way to do this is take the valve off with the nipple and the other half of the union still on there, and then I can take those off when I have it on the ground. All right, guys, what I didn't take into consideration is that when you pull this gas valve apart, basically the whole burner assembly loses all structural integrity and wants to fall apart. So now I have to kind of realign things and put the burner tubes back in. So bear with me just 1 minute here, guys. All right, let's put our flame rod back in the correct spot here. Not even the right orifice. Or am I just seeing things? Yeah, that runner's definitely the wrong size. Well, that was a waste of time. I guess I should have tested those orifices on this new runner before I did anything else, huh? Here we go. So you can tell I got my new gas valve in there, spark wire, flame rod, everything's been reattached. This flame rod is in the right spot now. I have my jumper wire here, and I have my spark igniter for the one that wasn't working hooked up to my ignition module. So only do this if you are a trained professional. Do not attempt this at home. Do not play with high voltage electricity, because that's real stupid. All right, so what I'm going to do is I'm going to power this on, and as soon as it initiates a call for heat, I'm just going to verify that there's a little spark going from this spark wire onto my runner, onto my little pilot tube, because I want to make sure it's landing on this pilot tube. If it's not landing on this pilot tube, then it's not going to ignite, obviously. So let's power it on, see what happens. Inducer's on. Indoor blower should come on in a minute. And again, while you're doing this, don't touch it, guys, because you could get a little bit of a shock. There we go. You guys can kind of see it there, sparking. So let's power it down before somebody gets electrocuted. Alright, so now that I know that it's sparking where it should be sparking, I'm going to put it back in place, hook the gas up, and in theory it should fire up on both stage 1 and stage 2. Alright, so let me get that handled. I'll bring it back in just a minute. Well, we got everything back in place. Everything's wired up again. I'm going to wait to make sure it works before I zip tie all those wires, clean them up a little bit. I got my thermostat bypassed. I did screw down my little relay right there. So let's power it on, see what happens. Inducer's running. Our blower should kick on in a second. Stage 1 is ignited. I smell gas, probably from stage 2, but stage 2 has not ignited. We do have ignition on stage 2 now. Excellent. All right, let's go around back and take a temperature rise, see what our supply air is looking like. So right here it says for 20 to 50 degree rise at 2.3 water columns of maximum external static pressure. 2.3 inches of water column, that's a lot. So anyway, I expect to see between 20 and 50 degrees of a temperature rise. My return air is 68 degrees. I only know that because of the thermostat downstairs that I looked at. Let's see what we got. We're at about 101. It's been running for about almost 10 minutes now. And we are in stage 2 heat. So it's about a 33 degree, 34 degree temperature rise. But right dead center in the middle of that factory spec. And we're still going up. All right, let's go back over here and see what's going on. Let's just make sure our stage 2 is heating. Stage 1. Stage 2 is hot. Very hot. Alright guys, we're all set here. Unit's up and running. Everything's heating. Everything's working. Everything's blowing like it should. So I'm going to get out of here. Because if you can tell behind me, we got a little bit of a snowstorm coming in. So I'm going to get out of here for the day. Thanks for hanging out with me, guys. I'll see you on the next one, alright? Don't forget to hit that like and the subscribe button somewhere down here, alright? We'll see you on the next one. Alright guys, here's our issue for today. We got this Lennox unit here, and apparently it's not heating properly. The customer says that it seems to be heating intermittently. One day it heats just fine, the next day it doesn't heat at all. So that's why I'm here. So what I've found out so far, just kind of walking around interviewing the manager, is that the dining room has 2 zone sensors and the thermostats are mounted in the office. Both thermostats for the dining room read above the set point. The actual temperature in the dining room is about 66, depending on where I tested it. And the thermostat is set to 88, or no, excuse me, the thermostat is set to 84 for this particular unit. And the display temperature, or the temperature I believe the zone sensor is telling the thermostat is 88. So what I'm going to do first is just kind of visually inspect this unit. I'm going to check my heat exchanger because it's old. I'm going to come over here, check to see if I have a W1 call. I'm going to check my belt. Basically, I'm going to make sure everything is mechanically sound before I really dive into the control side of things, all right? Alright, we don't have any fault codes. I don't see anything that looks like it's been on fire, except for that manual. That's just rotting away because it's probably been sitting in water for 20 years. No, I don't see anything out of the ordinary here. If we look over, right over here, we do not have a call for W. I'll double check that in just a second. But if we did, our little W1 light, which is, I believe, the third one from the left, would have been lit up. But it's not. So, let's check our belt. There we go. Alright, there's our blower assembly. Nothing crazy. Direct drive, little blower. So that looks alright. Let's go check our heat exchanger. Let's check this heat exchanger real quick. Yeah, not the healthiest looking heat exchanger. That's for sure. Get my flashlight in there. I'm sure it's cracked somewhere. Alright, I'm gonna have to stick my head in there and start jamming rust spots with my screwdriver, see if we got any weak points here. Alright, so my heat exchanger didn't have any physical cracks in it. However, as you saw, the condition is pretty bad, so I'm going to recommend they replace it anyway. So what I'm doing now is just checking to see if I have a W1 call. I'm just checking W1 to common. Yeah, I don't have nothing, just as I suspected. So now, what we're going to do is just test it in heat mode. There we go. And we want, we'll do H10. Hold it down, and our heat should come on. There's our inducer. Alright, we have ignition. I can hear our sparker has stopped, so it must have recognized the flame. We'll let that run for just a minute or two, make sure it doesn't drop out. Alright, so we're done testing our heat. Hold down this black button. The little decimal point goes away. Now I'm going to push this shift dip switch to the left, and then unit test to the left, and then it should go back to its normal standby mode. Alright, so the unit is mechanically sound. So now we need to figure out why our zone sensors are so far off. The dining room at this location was just recently remodeled, and what I've seen in the past is sometimes they'll move the zone sensors or forget to reattach them, or they'll put them like up in the ceiling or hide them behind ice machines or crazy stuff like that. So that could be why our zone sensor in the dining room says it's 88 degrees when it's actually about 65. So let's go back downstairs and start tearing stuff apart and seeing what we can figure out. Alright, here's our zone sensor. There. Let me show you what the thermostats say. As you can see, our thermostat thinks that it's 94 degrees in the dining room. Alright, real quick guys, I am going to just ohm out this sensor, see if we're accurate at all. Online I found a chart we can compare it to. We know the ambient temperature is 65, so it should be about 13,000 ohms. Alright, 12.9k ohms, so it's about 13,000, which is right about where we want it. Now I did verify that our thermostat is set up to read a zone sensor. I'm going to go back and double check my thermostat to make sure the calibration wasn't changed, because we are about 20 degrees off of actual temperature versus what the display says in the office. Alright, well, since we programmed the thermostat to properly read that zone sensor, our heat is kicked on and we're putting out about 93 degree air and rising. So we got about 72 degree air going back to the unit. So we're looking at about a 30 degree rise. Climbing up to 102. Yeah, this thing's working pretty good. Alright, we're up to 123 degrees. Now this particular unit, temperature rise is 40 to 70. You can check out the data tag that'll insert right here. So we can get up to about 140 degrees on this unit because we're pulling back 72 degree air. Alright, looks like we leveled off about 140 degrees here. It is nice and hot. Hey, what's up YouTube? Just want to do a quick recap here. What we had was just a thermostat that was set to read a 20K ohm sensor, and apparently what we had on the wall was a 10K ohm sensor. Now in the manual for that 10K ohm sensor, or for that sensor anyway, there wasn't anything that really indicated how to tell if it's a 10K ohm sensor or a 20K ohm sensor. I looked through the sensor manual as well as the Honeywell thermostat manual. I didn't see anything that indicated either way. So if any of you guys watching this can tell me how to decipher between a 10K ohm sensor and a 20K ohm sensor, please leave me a comment, shoot me an email, let me know. I don't really know why. Like I said, I researched it, looked through the manual, couldn't find an exact reason why that sensor is apparently a 10K ohm sensor, because as you saw, when I have it set to 20K ohms, it reads way off. I said it's 10K ohms, it reads exactly right. So obviously it's set up to be a 10K ohm sensor. Now why that is, I don't know. But we got it fixed, and like I said, that heat exchanger on the rooftop unit you saw, it was pretty old, so I'm going to recommend they replace that. There was no separation, there was no cracks, so I didn't shut it down or anything like that, but I did explain to the manager that it's in rough shape, and I'll be providing a quote for that as well. But other than that, guys, I'm going to get out of here, head to my next call, and see what other kind of adventures I can get into for today, alright? So stick around, maybe I'll see you on the next one, alright? Go ahead and hit that like and subscribe button for me too, will you? Hey, what's up YouTube? Hope everybody's doing good out there. Hope you guys are staying clean, staying safe, all that fun stuff. Anyway, I got a walk-in freezer today that apparently won't turn on, so should be interesting. I'm hoping it's interesting anyway. Alright, so stick around. I'll bring you along for the ride. Alright guys, we are inside our little walk-in freezer, and it is currently running right now. But if you'll notice, our frozen droplets of water up there are indicating a possible defrost issue, so we're going to look into that as well. Just a little tiny one today, guys. Here's our condensing unit. Sight glass is nice and full. Judging by the frozen droplets of ice on the ceiling of the walk-in freezer, I suspect a defrost problem. And then I come out here and I find our defrost clock has basically 4 defrosts per day, all at about an hour each. So I'm assuming whoever set it up this way is depending on that defrost termination fan delay to kick it out of defrost. The kitchen manager said that it just kicked on a few minutes before I got here, and he also mentioned that it does seem to stay in defrost for extended periods of time. So I'm just assuming at this point that a defrost termination switch isn't bringing it out of defrost. Instead, I believe it's just timing out. Now, due to the current pandemic, I'm sort of limiting my trips inside and outside of the building. So what I'm going to do is I set it just a hair before it goes into defrost, and I'm going to stand around and make sure that it times itself and it's able to move itself into defrost. And then I'm just going to monitor my X and my N terminals here, because right now they're open, and when it goes through defrost and eventually when it gets warm enough, that switch will close and it should time itself, or it should should close this switch between here. So that's what I'm going to monitor when it goes into defrost. I also got my garden hose hooked up because we're going to clean this condensing coil while we're on site. It's not terrible, but it's a little impacted. It'll be the first condensing coil cleaned of this year for me anyway. Look at all that gunk coming out of there. Dang. It's a good one. This is how Dr. Pimple Popper must feel. Now here's something I like to do, especially with these microchannel coils. After I wash them out, I like to take some nitrogen, since I don't have a leaf blower, just kind of blow all that water out. Because if you don't, you run the risk of the unit shutting off on high head pressure, or if the condensing fan motors are able to pull through that water-soaked coil here, then they're probably going to drop your head pressure, and your TXV is not going to feed properly. So you could have a couple different issues if you don't do this. So I recommend you do it. Alright guys, here's a close-up of the inside part of our condensing coil right there. As you can tell, you can see through it. However, it looks like there's a few spots that still have some gunk sticking to them. So I'm going to hit it with the hose again real quick. We're about 20-ish minutes into our defrost, and I'm just going to check across my neutral and X terminals. I don't know if that's showing up on camera very well, but we have basically no potential difference between X and neutral. So we should not be in defrost. Maybe we might have a bad defrost timer on our hands, guys. Alright, we're just checking our defrost termination switch right up there. It's got the black, brown, and red wires going to it. There's my black lead on my brown wire. That brown wire goes to the X terminal, which is right over here. There we go. That's my X terminal. So I'm going to check brown to my neutral, which is red, right down here, number 4. Just see if I do a continuity. Alright, so let's see. I should have continuity there because I believe my defrost termination switch is closed. And it is. So my defrost timer should have kicked out on early termination. But it didn't, so I'm going to swap out that defrost timer real quick. Real quick, guys, I wanted to point this out. I've never actually seen one of these terminals before. It's just a fork, but it spins on like a wire nut. I don't know if you can see inside there, but it's threaded just like a wire nut. At first I thought I had some loose connections all over the place, but it's just got some fancy little wire nut forked eyelet things, I guess. Oh, weird. If I'm going to use a forked connection, I still prefer to crimp it on, I guess. Old school way of thinking. Well, I hope you can hear me, guys. I'm sort of in a tight spot here, right next to another condensing unit that runs nonstop. So you'll notice I have my new defrost timer installed. I have it set up for 6 defrosts at 30 minutes each per day. Now, right here, you'll notice that I have my arrow pointing towards an absurdly long defrost. Now, since my defrost termination switch is closed in the position where it's going to kick it out of defrost, I'm going to basically start this unit up in defrost, and my defrost termination switch should immediately tell the defrost timer that it's too warm and we need to go into refrigeration mode. So I'm going to go hit my disconnect and see what happens. All right. Dun, dun, dun. Alright guys, so notice we are still in defrost. My little experiment didn't work as well as I assumed it was going to. You still have a potential difference across X and neutral, so my defrost termination switch is closed again. So my assumption is, since I've had this whole unit off for a little while, it was still 7 degrees inside the box, so without those heaters running, since I had the unit off to change the defrost timer, without those heaters running, my defrost termination switch closed back into the position of black and neutral, which would have been red, so my fans would have come on. So we're just going to wait a little bit, let it defrost some more. Shouldn't take long for that termination switch to kick us out of defrost. Well, it's been about 5 minutes maybe at the most since that last clip. Just make sure we got 0 potential difference, so our defrost termination switch is closed and we are back in refrigeration mode. So now what I'm going to do is just monitor my box temperature and go from there. So we got a clean coil, new defrost timer. Let me fix these times. There we go. Contactors look good, wires are nice and tight. Unit looks in pretty good condition. I don't see any other red flags with this unit. So let's just wait for it to hit temperature now. So I was just in here setting up my temperature probe, and I noticed that a little transformer just sort of hanging out. Not real sure what it does, but maybe, oh, I bet you it controls the display for those temperature probes. It's just got a little red digital or LED display on the outside. So anyway, we're down to 10 degrees and dropping. Alright guys, we just dropped below 0, so I'm gonna call it good. Hey, what's up YouTube? Real quick, now that I'm back in the safety of my COVID-free work van. Anyway, we just had a bad defrost board on that one. Now, I think I am going to quote to replace that defrost termination fan delay switch just as a preventative measure, sort of just to be overly cautious, I suppose. But other than that, I didn't see any other red flags. Yeah, anytime you guys ever question those defrost termination switches, I recommend that you just put it in a manual defrost, set it up for an hour, and just watch the X in the neutral terminal. Obviously, if you walk in there and your evaporator coil is a solid block of ice, you're not going to do anything. It's probably not going to defrost enough with just those heaters to the point where that defrost termination switch is going to kick it out of defrost. Because it's a defrost heater. Frost. It's not a de-icing heater, it's a defrost heater, so remember that. So if you ever question that, and assuming you just have a normal amount of frost buildup on your evaporator coil, like I said, put it in manual defrost, set it up for an hour, and then just watch it. On average, what I've been noticing since I've been doing this little experiment, usually 20-30 minutes it'll kick it out of defrost. And again, that varies depending on how often people are walking into the cooler or the freezer. the amount of frost that's on there, how many heaters it has, where the defrost termination switch is located, where the heaters are located. There's a lot of variables, but 20 to 30 minutes on average is probably a good rule of thumb. Anything longer than that, you probably have an issue. But anyways, guys, that does it for today. Hope you enjoy the video. Thanks for the support, as always. If you guys do like the content, hit that like button and the subscribe button somewhere down there. If you have any comments, questions, suggestions, you want some free stickers, I don't care, shoot me an email. CuriousHVACguy@gmail.com. I'll put it along the bottom of the screen there. And yeah, another thing too, guys, if you guys don't know already, every Friday at 9 p.m. Eastern on the HVAC Overtime channel, me and the other guys from the HVAC Overtime gang get together and we do a live stream on YouTube. So tune in, 9 p.m. Usually starts about 9:05 p.m. Not gonna lie, we're usually a few minutes late. But 9 p.m. Eastern, HVAC Overtime channel. All right, guys, we'll see you there. Alright guys, we are back on location, back to this walk-in freezer that we had an issue with the frost buildup. As you can tell, we still have that same issue. Now this is my third visit here. The initial visit was the video I released, I don't know, 2-3 weeks ago. And I had a second visit that I wasn't able to film anything on, and in that visit I replaced my defrost termination fan delay switch. Not because I found a problem with it, only because the manufacturer wanted me to replace this. This is a warranty deal, so I am basically just the hands and eyes of the manufacturer. Anyways guys, I'm going to put it in defrost and kind of just re-verify that my defrost termination switch is taking it out of defrost. So I'm going to run 2 consecutive defrosts right here. So we're just about in defrost, and I'm gonna put it for, we'll say, 45 minutes. We are 35 minutes into this defrost cycle. Again, air temperature in front of the evaporator, 60 degrees. Behind here, 112 degrees. The water droplets on the ceiling are starting to thaw, finally. Surface temperature next to the termination switch, still 38 degrees, so that's not going to open yet, or close rather, and kick us out of defrost. Tubing on our evaporator coil, it's 85, 95 degrees. Alright guys, here's our final numbers. 37 minutes into defrost, we finally came out on the termination switch. 60 degrees, and 113 degrees behind it. Surface temperature near it is still about 40 degrees. That's our final numbers, guys. I'm going to call tech support, let them know what I found, and go from there. Hey, what's up, YouTube? So we are back on site at this walk-in freezer defrost issue, and per the manufacturer, I am here today to replace the defrost clock. Now, I told the manufacturer I don't believe that's going to do any good because I haven't been able to find a problem with that defrost clock. Every time that I put it through a defrost, I am measuring the voltage at my X and my neutral terminals, and it's that termination switch is open until, I don't know, 20-30 minutes, whatever it is, whenever it goes into refrigeration mode. I don't have any sort of delayed reaction from my defrost clock. But yeah, for right now, I'm going to change out this defrost clock, run it through a couple defrosts, basically repeat my experiment, and see if we get any different results, all right? So I'll throw in some highlights here and bring you along for the ride, all right? All right, guys, here we are inside our walk-in freezer, of course, which, if you didn't know what the inside of a walk-in freezer is, you need to watch more YouTube videos. Anyways, as you can tell, we don't have as bad of a ice buildup problem as we did last time. I'm going to see if it maybe just recently came out of defrost. No, it didn't recently come out of defrost. The only thing I did last time I was here, it looks like somebody might have taking one of these out, but I put 6 defrosts at 15 minutes each. So I just shortened our defrost time so it wasn't in defrost as long. I think that's the key to this whole thing. I'm going to replace that defrost clock, like I said, run my experiments, and probably have the same results as I did last time. Alright, we are now 39 minutes into our defrost cycle. Air in front of the evaporator is 62 degrees. We got about 100 degree air behind our evaporator. And let's just double check this brand new defrost termination switch that I installed on one of my previous visits. There we go. As you can tell, our defrost termination switch is not trying to kick us out of defrost. Let's take a quick surface temperature near the termination switch. Now that is a surface mounted defrost termination switch. So if the surface next to it is still 40 degrees and that switch trips around, I think the manufacturer said 55 degrees, then we still have a ways to go until that termination switch trips in the position that it's in right now. And we're just about at 40 minutes on a defrost with a coil that's obviously clean. Well guys, I didn't expect it to go this long. We are 45 minutes into our defrost. 62 degrees in front. 114 degrees behind the coil. Let's just double check our termination switch right here at X and neutral. So it is still open. We have a potential difference. So our termination switch is not trying to kick us out of defrost yet. And again, I have my defrost time set to an absurd amount, like 2 hours, just so I can see what temperature this termination switch kicks us out of defrost. Surface temperature is getting about 44, 45, so it should be coming out of defrost soon. Alright, 50 minutes. We just came out of defrost. I was standing outside and I could hear my condenser kick on. 61 degree air in front of the coil. 118 degrees behind the coil. Let's just simply double check our termination switch here. No difference. Termination switch is closed. Alright guys, quick update. I spoke to the manufacturer and they apparently are okay with the results. So I'm just going to do a follow-up visit in the next couple days and see what happens. Now before I left, they did ask me to change the defrost time to 4 defrosts per day at 30 minutes each. So we'll see what happens. I have a feeling in the next couple days I'm going to come back and I'm going to see more frost buildup because, in my opinion, we're just going back to square one. I do have a new defrost clock, which I don't think was a problem. I do have a new defrost termination fan delay switch, which I also don't believe was the problem. Yeah, I don't know. That's a different one for me. But alright guys, I'll see you in a couple days when I stop back for this follow-up visit. Alright guys, this is the follow-up video. We are back on site. It's been about 4 days since my last visit here. And almost as I predicted, that defrost clock set to the same time isn't really doing any good. As you can tell, we're starting to get the frost buildup again. It's right there, coming in through the seams. But we're getting the telltale signs of over defrosting, these little droplets hanging down and freezing like that. So I'm going to go back to the manufacturer and tell them basically what they asked me to do isn't working. Look at all that. Depending on what the manufacturer says, there may be a follow-up video to this, but if not, thanks for watching. Hey, what's up YouTube? So it's been about a week since that last clip you saw, and during that week I've been going back and forth with the manufacturer, trying to figure out a way to solve this defrost issue this customer's having. Now, my suggestion to the manufacturer was to put a defrost termination fan delay switch on one of the return bends of the evaporator coil, so it has a better chance of sensing actual evaporator temperature instead of the surface mounted one that we have. Or I suggested that we possibly put in an off-brand like a Ranco or a KE2 controller in there, so it's got a probe that goes right into the evaporator coil itself to sense evaporator temperature during defrost, so it kicks it out of defrost a little bit sooner. In my opinion, the switch that they have doesn't accurately sense evaporator temperature. So anyway, back to the story at hand. The manufacturer wants me to replace the defrost termination fan delay switch again. So I'm going to go in here, replace the switch, and we're going to conduct yet another defrost experiment while I let it go and defrost, see how long it takes, and sort of monitor the temperatures around the defrost termination switch and the evaporator coil to see what happens. All right, so stick around. Hopefully something cool happens. All right. All right, guys. Inside of the box here, of course, as you can tell, we obviously still have the same problem going on. This is my defrost termination switch that they want me to install. Right up inside of there. First, let's see what our last defrost was. Okay, so it hasn't been a defrost recently. I don't have a real good place to set my little camera here, so I'll try to do this one-handed. Not too terrible, but it's kind of hard to reach. Drop that screw. There we go. See? Just a surface-mounted defrost termination switch. Here's our new one. Pop that guy right on there. There we go. All right. There's our brown wire. Goes to our defrost termination switch itself. Our black wire. Go. Making sure none of your wires are actually touching your heating elements. Okay, be sure of that. Alright, right up here to our red wire. All right, our new defrost termination switch is installed. Kind of tuck some of these wires up out of the way. In case you guys notice this little wire hanging here, that little wire goes to this relay up in the corner. And apparently that relay is just a high and low speed for our fans. When this jumper wire is disconnected, our fans are in constant high speed. When the thermostat is satisfied, I think it goes at a low speed. So, all right guys, well, I'm going to turn the box on, let this defrost termination switch satisfy, make sure our fans are running, and then we'll do our little defrost experiment yet again. Alright guys, our box is at -4. We're not even in defrost. You can already see just moisture coming through for whatever reason. Not real sure. Not real sure exactly what's going on in this case, but anyway, we're going to put it in a absurdly long defrost again, so I can just make sure that it's cutting out on termination instead of time. All right, I'm going to set up a temperature probe right up behind the evaporator, one in front of the evaporator, and then I'll be monitoring that defrost termination switch about every 5 minutes. All right, so let me turn this off and turn my timer on. Real quick, 20 minutes into our defrost, you can see yet again we have a fog of moisture in the air. We are still in defrost. We're up to 90 degrees behind our evaporator coil. Let's check this real quick. Bingo bango. Not trying to get out of defrost yet. Air in front of the evaporator is 40 degrees. Surface temperature next to the termination switch is 30 degrees. So my best guesstimation, we're going to be in defrost for at least another 20 minutes. Alright guys, we're 30 minutes into our defrost. Still got a fog inside of our box. Air temperature in front of the evaporator coil is 60 degrees. Let's check behind it. Alright, look at that. 11 degrees. Now, let's just make sure our defrost termination switch isn't trying to kick us out of defrost. And it's not. Last but not least, surface temperature near the defrost termination switch is 40 degrees, so probably got about another 10 minutes, I'm guessing. See, some of these return bends are 60, 90, 80 something, 90, 55. So all the return bends on my evaporator coil are well above freezing temperature, right? So now wouldn't it make more sense to have a defrost termination fan delay switch on one of these return bends? I mean, all the ones that I'm just, testing the surface temperature on are well above freezing. 90, 60, 80, 55 is the lowest. And then we come up here, and our surface, where our defrost termination switch is mounted to, is still at 41 degrees. Well, let's give her some more time. Hey guys, so I apologize. I was not able to get any footage of the unit coming out of defrost. My phone was down to about 2%, so I came out to my truck to charge it up a little bit. And by the time I got back in, it had just come out of defrost on the termination switch. It was about 38 minutes, I'm guesstimating. I walked in there and checked it before I came out of my van, and that was about 35 minutes into it. Yeah, so it took about 38 minutes. And again, in my opinion, that's way too long because the evaporator coil was nice and clean, long before the 38-minute mark. And as you saw, when I was checking the return bends on the evaporator coil, a major portion of that evaporator coil was already way, way, way above the freezing temperature, way above 32 degrees. I mean, talking 80, 90, 60. I think the lowest return bend I measured, and this was around 25, 30 minutes into the defrost cycle, the lowest temperature of the return bend was, or the return bend with the lowest temperature rather, was 55 degrees. So, again, in my opinion, I think they would be better suited to have a defrost termination switch that's mounted right to one of the return bends. But just my opinion. So I don't think this repair is going to do any good. I don't believe replacing that defrost termination switch will solve anything in this case. So we'll see. I'm not sure if there will be a follow-up to this video. So anyways, guys, that's all for today. Hope you enjoyed the video. I know it's kind of a long, drawn-out process, but I wanted to highlight this particular case because of the ongoing issues and the struggle with dealing with the warranty and the manufacturer and all the fun stuff that I dealt with here today and over the last few weeks. So anyways, guys, hope you liked it. Hope you got something out of it. If you do like it, hit that subscribe button for me. Even that little bell if you want. I don't care. And yeah, share the video with your buddies and your pals and whatnot. And if you don't already know, Friday nights, Friday nights, the place to be is on the HVAC Overtime channel. I'm there every Friday night at 9 o'clock. Me and a couple other guys just kind of hang out. We shoot the breeze, talk about the industry, talk about mostly HVAC related stuff. Sometimes we don't. We get off on a tangent. But yeah, tune in. Friday nights, 9 p.m. Eastern, HVAC Overtime channel on YouTube there. I'll put a link down below for you. We'll see you guys in the next one. Well, it's been a little while since I've posted much new content because this whole pandemic thing has kind of slowed everything down, and I haven't really had anything interesting to film or even anything interesting to say. So I figured, what the heck, today I'll give it a try. I got a makeup air unit. Let's see, right there. It's kind of noisy, so I'm gonna go fire it up and see what the complaint is here. Ready? Yeah, sounds like some rusted out old disc brakes. Now let me pop these panels off, see what we're dealing with. Well guys, this might be a short video. Look right back there. See if I can get in there. Yeah, it looks like our bearing has just sort of disintegrated. Ruined our shaft, our drive shaft. And then sort of, yeah, it basically destroyed the little bracket that holds the bearing in place right there. Interesting. Now these pulleys are all just rusted. They're not bad. I mean, they're just not in the best shape at all. I'll probably do new pulleys on both sides, and I'll probably end up just doing this entire blower assembly, because by the time I take everything apart, I mean, I gotta replace this bracket anyway. Try to dig that blower out of there, take that old drive shaft out of that blower somehow, put a new drive shaft in there. Yeah, we'll end up just quoting new blower assembly. Part of me wants to just quote that motor as well, but I really have no reason to, other than age. But I'll talk to the manager, let him know my thoughts on the whole thing. But yeah. Well guys, that's one of the reasons I haven't been able to film much lately, is because I get to jobs like this and they're really simple, which, don't get me wrong, everybody likes a simple job once in a while, but I get kind of bored doing simple stuff. I'd like to have some, a good head-scratching problem to solve, something to really dive deep into. Quick side note here. As I'm walking around this rooftop, I'm noticing some of these condensing coils. They're not terrible, but where I'm at, we're in cottonwood season. So we're starting to build up some cottonwood, especially, I don't know if you can see in there, but especially underneath there. So since I'm already up here on the roof, I went to the manager and said, hey, how about you put a work order in? I'll clean these condensing coils while I'm at it, and we'll kill two birds with one stone. So yeah. So sort of a way to, I don't know if you want to call it drumming up business, but, obviously that problem's just going to get worse before it gets better on its own. And like I said, I'm already here, so heck, why not? So that's what I'm going to do, guys. We're going to end up quoting this makeup air unit right over here. I'm going to quote all that stuff like I said, and then we'll see if it gets approved, and we'll come back and throw it all in there, all right? So, yeah. For now, guys, I'll see you on the next one, and hopefully that one's a little more interesting. Take care, guys. Hey, what's up, guys and gals? So today we're going to talk about defrost circuits. Specifically, a basic defrost circuit that you'd see in your standard walk-in freezer, or I guess what I would consider standard in my market. This right here is a DT-AV40 Grassland defrost clock. It's a 208-230 model. It's basically standard in my market. That's why I like to train on it. So that's why we're talking about it today, because it's standard in my market. You may see things different in your market, but from what I can tell, a lot of people see these in the commercial side of things anyway. So let's take a look at it, all right? Now, quick disclaimer. I know there's a bunch of videos online talking about defrost circuits and everything. I really just wanted to give my 2 cents on it. Plus, see if any of you guys like my little visual aid that I made, all right? So anyway, let's get to it. All right, guys, here's the little visual aid that I made, sort of outlining a standard defrost circuit. So real quick, let's identify some components here. Right there is the cover to our defrost clock. I'll put a wiring diagram up in the upper left-hand corner so you guys can follow along with that. Right here, that's just our incoming power source. The toggle switch is just to turn the display on and off. You won't normally have a toggle switch in a defrost circuit like that, so don't think that's standard. That right there is our 120, 240 volt DT-AV40 Grassland defrost timer. Right here, this light bulb, obviously, as it's labeled, is refrigeration. It's a green light bulb that will simply indicate when our refrigeration mode is on. That one right there is a red light bulb that will indicate our defrost heaters are on. Although obviously I don't have defrost heaters, that's why I'm using a light bulb. Right over there, that light bulb is going to indicate our fans are coming on. Now, these 2 switches that I have here, I still need to get a cover for this one. But anyway, this is our defrost termination switch, and this is going to be a fan delay. Now, real quick, let's talk about that. In my world, I normally see this component. This is a combination defrost termination fan delay switch. It's a pretty simple device. You can find this in your system, or sometimes you'll find it separate. You'll have just a defrost termination switch, and then next to it maybe a fan delay switch. Normally I see the combination like this. So real quick, let's talk about this. Now this is our neutral. In this display, this is a 120 volt display. So I am referring to this wire as my neutral. If you get into on site, most of the time you're going to find that this defrost circuit in an actual walk-in freezer is going to be 208, 230. So this won't actually be a neutral per se. It will be like your line 2, as you'll see in the wiring diagram. It's labeled line 2. But in this display, it's called a neutral. So remember that as I'm going through this. So this line 2 or neutral is hooked up to the neutral side in our defrost clock, of course. This brown wire, this goes to our X terminal on the defrost clock, and this black wire goes to the fan switch on our defrost clock. Now let's say our evaporator coil just came out of defrost. Our temperature right now on the evaporator coil itself is, say, 55 degrees. Now, what will happen is the defrost termination switch at 55 degrees will trip. So our red and our brown wires will basically be connected, and power will be routed to the X terminal on our defrost clock, as you can see in the little display. Now when that happens, our defrost clock switches over to refrigeration mode immediately. Our thermostat will open up our liquid line solenoid, gas will rush into the evaporator coil, pressures will rise, our pressure switch on the condenser will close and activate our compressor. Now, our fans won't come on immediately because you want to allow a little bit of drip time to let that melted frost drip off the evaporator coil. Because if you don't, you're going to get a lot of little droplets blowing out of the evaporator coil all over your product, all over the walls, all over the ceiling. It'll be a huge mess. So what happens is that evaporator is going to run without fans until the actual temperature at this combination switch, or if it's got a separate fan delay switch, until that fan delay switch cools down to about 25 or 35 degrees, depending on the manufacturer and the application. Once that happens, I guess we'll use this as an example. Once this switch cools down to about 25, 35 degrees, these two wires are basically connected and our fans come on. And then we just go into our, basically standard refrigeration cycle. Fans are running, compressors are running until that thermostat is satisfied. All right, guys, let's fire this up and get on with it. I got my meter here just so we can kind of highlight some circuitry as we go. Keep in mind, this is a 120 volt display, and in a real world situation, you're more likely to find 208 to 30 volts going across most of these circuits, so keep that in mind. All right, so we come on in refrigeration mode. Now let's pretend that we just walked into this walk-in freezer and it's been running for however long it's been on all day, we'll say. And it's just about to go into defrost, as you can tell. But first, let's double check a few things. Now, number 4, this is our number 4 circuit right here. That goes to our fans, our thermostats, basically the cooling cycle, we'll say. Now across this, I have 120 volts. Again, that would probably be 208 in your world, in a real world situation. Now, let's also double check our number 3 circuit, which is our defrost heaters, just to make sure those aren't on. Like I thought, we're basically at 0. My meter might be getting a little flaky, or I'm just getting a little bit of back voltage coming back from one of my circuits here. So, for the sake of argument, number 3, our defrost heaters do not have any power. Now also, X and neutral, right here, let's pan over here real quick. This is our termination switch. I'll put that wiring diagram up in the upper left-hand corner, guys, so you can follow along with me. But neutral and X right here is our defrost termination switch, which would be our red wire and our brown wire inside of that switch. Now, right now, we should have voltage because that switch should be open in this position. Obviously, the unit's been running, it's cold, our fan delay is not activated, so the wires going from the fan delay, which would be our red and our black, should be closed. Our red and our brown should be open. So right now, this will be an open switch. We should have a potential difference of 120 volts, which we do. Okay, so keep that in mind. All right, now I'm not going to wait for that defrost clock to go into defrost on its own. We're going to put it in defrost. I understand it's an absurd amount of time, but this is just for display purposes. So right now our defrost heaters are on, as you can tell by our red light bulb. And let's take a quick reading here between neutral and our number 3 circuit. So our defrost heaters have 120 volts. Again, real world situation, you're probably going to find 208 volts. Let's check our termination switch again. Our termination switch is open still. That's why we have a potential difference. So now let's say we've been heating and heating and heating, and our evaporator coil is at 55 degrees. Now our termination switch is going to switch from the brown and it's going to switch from the red and the black wire, which was our fan circuit when the unit was cool. And since the evaporator is nice and hot now, it's going to switch over to red and brown, which is going to be our defrost termination switch. So let's pop this real quick. It just switched over. It kicked into refrigeration mode. We should have a closed switch right here now. 0 potential difference. Our termination switch is closed. As you can tell, the arrow indicates that we should still be in a defrost cycle. Obviously, we are not, because we have a green light bulb, which indicates our compressor is running at the moment. Now, as I explained a little bit earlier, our compressor is going to run our evaporator coil is going to continue to drip and drip and drip. It's not a set time, just however long it takes for that evaporator coil to reach about, we'll say 25, 35 degrees, right? So let's say our condenser has been running, the evaporator is nice and cool, it's about 35 degrees, and our combination defrost termination fan delay switch switches over from red to brown to red to black, which is our fan circuit. And our fans come on. So right now we are basically right back where we started, in refrigeration mode. So the defrost clock will continue to move under its own power, and eventually we'll go into defrost again. And once we get into defrost, start warming everything up. We'll warm everything up, everything warms up, and what'll happen, now keep in mind I have two switches here, guys. What'll happen is our defrost termination switch, first we gotta turn this, because inside that combination switch we can't have two circuits on at the same time. So as that combination switch switches over from red to black, which is our fans, and it switches over to red to brown, this goes off, this comes on, we go into refrigeration mode. After it cools down, maybe 5 minutes, evaporator gets down to 25 degrees, then our fans will come on. Make sense? Alright guys, I hope you enjoyed this little video. If you have any questions or comments or anything, leave them below or shoot me an email. CuriousHVACguy@gmail.com, alright? Enjoy. Thanks for watching. Alright guys, here's what we got today. We got this 10-ton Lennox unit here that doesn't want to cool. Looks like it's a 10-ton. I'm guessing it was manufactured in 01. My thermostat right now is set to 68. I had to pull the condensing fan cover off because I couldn't feel any air coming out, and I just wanted to verify that our condensing fan motor wasn't running. Look what I found. We got our Run Cat Bandit there. So that's pretty exciting, huh? Look at that crap job, man. I'm almost afraid to touch it. So, anyway. I've kind of been poking around here a little bit before I turn the camera on. And initially what we have here is our 24 fault code, which is the S88 low pressure switch. S88 low pressure switch, right there, bango bango. In other news, right here, somebody has disconnected this low pressure switch on this side and just apparently put a wire knot on there. So, yeah, I'm gonna throw gauges on both sides. Now, right now, all three of my contactors are pulled in. Compressors are very, I would say, pretty hot to the touch. I can touch them, but it's not comfortable. Before I turned the camera on, I did have this off for a quick minute, and I ohmed out both compressors, and all three legs are open to each other, so both compressors are off on thermal overload right now. If I had to guess, this one's probably just maybe seized up, maybe it's got a mechanical failure from having a leak and possibly running without refrigerant in it. I'm not sure. I'm just throwing out ideas. This one over here, probably the same thing. Low pressure switch has been bypassed, so who knows, it could be running without any refrigerant, and again, just mechanically seized up. I don't know, we'll have to get some gauges on there and see if there's anything left inside there, and then do a quick leak check. So yeah, all three contactors are pulled in. None of my condensing fan motors are running right now, so let's check this out real quick before, let's see, where is it? Right there. So B4 and B5, these are our outdoor fan motors, and one of them is controlled by the K68 relay, the other is controlled by the K10 relay. So if we come up over here, the K68 relay just looks like it's a straight shot from the board, nothing in the way. Our K10 relay though is controlled through a couple of low pressure switches right here. S84, S11, low pressure, low ambient kit, which are, let me show you where those are. Right back here, and this is our S84 up top. That's our S11 right there. Now obviously with our compressors not running, we're not going to have any discharge pressure. So that is why I'm assuming this condensing fan motor over here is off. I don't know if you can hear that. Oh yeah. Also, do not ever stick your hand in a powered up condensing fan motor, okay? Unless you're a trained professional. So now this condensing fan motor, this side is hooked up to our low ambient kit. 84, 1, I should realize that because the 2 would have been upside down if I was reading at 78. 84, okay, so, yeah. Let's just walk back and forth here a few more times, huh? Yeah, so right there, S84, 1, 2, 3, that's our low pressure switch. That's why that condensing fan motor is off. The other one is just seized up, so we're gonna need to replace that one. And we're back. As you can tell, got my gauges hooked up here, and we're flat. So this is a R22 system, so I'm gonna drop in a little bit of this highly illegal R22, and then we're gonna back it up with some nitrogen, make sure we got lots of pressure, and then we'll sniff out these leaks on this circuit first, and then we'll move over to this circuit. As soon as I put refrigerant into this system, it started spewing out from somewhere. I can hear it, just can't seem to see it. Or oh yeah, it's back here. There it is. Messy. That was a pretty easy leak to find. Let's get started on this side. Alright guys, so we are on this circuit, which I believe is circuit number 1. And it was flat, nothing in there. So I dropped in a little bit of R22 and I pressurized it to just above 150 psi. So, nothing obvious like the last leak way over there. Alright guys, so kind of boring. This side, I wasn't able to find a leak. I even took my manifold off here just to check my Schrader ports. I didn't find an active leak anywhere. Swept the evaporator, swept the condenser, swept as much of the line set as I could. Nothing, so I'm not sure where the refrigerant went. I guess it all just got used up in the refrigeration process, huh? You know, just to be extra thorough, I'm going to pull these wires off here just to be extra thorough. Keep in mind, these wires just go straight up to the bottom side of that contactor, and there's nothing else on that contactor, so I'm 900% sure that I'm reading it correctly. So I'll just pull these off just to be sure. All right, let's hit this disconnect. All right, well, hopefully that picked up on camera. But initially my inrush current was about 303 amps, and then it settled down to about 90 before the thermal cut out. So that compressor is also mechanically seized. Yeah, so keep in mind this unit's 20 years old. Both compressors are failed. I have a pretty bad leak over there. It's going to require some repiping. Change out the filter dryers. The one condensing fan motor over on that side is bad. I'm going to have to replace that condensing fan motor. I don't like the look of any of these contactors, so we'll do all 3 capacitors for our new condensing fan motors. New ice cube relays back there. And then we can verify operation after that. That blower motor looks like it's probably original. Belt looks decent, kind of floppy. Pulley's not lined up properly. Look at the the sheave, whatever you want to call it. Looks decent, but our keyway is popped out. You know what? I almost forgot too. We'll have to check that heat exchanger, because if they have a cracked heat exchanger, I mean, there's no way I would even touch this thing. It would make no financial sense to do everything to this unit to get it up and running. So let's go check that heat exchanger real quick before I completely condemn it and then start a quote to repair it. Alright guys, here's our heat exchanger. Now I don't see any actual cracks. I mean, don't get me wrong, heat exchanger by any means does not look healthy, but I don't see any actual open cracks in this. However, based on the condition, the amount of rust buildup on there, I would still quote to replace that heat exchanger, which I'm going to notate in my quote when I get my long list of components it needs to get back up and running. So yeah, I think you guys will agree that it's probably makes more sense just to replace the unit, right? Alright guys and gals, so today we are looking at this Hvac unit here, and the reason we're here is because they are having a little bit of a leak downstairs. It's coming out of I believe it's the return vent. I don't know, one of the vents it's leaking out of. It's probably going to be the return. But the reason we're leaking is pretty simple. It's because there's no P-trap on our condensate line. Got some extra condensate line there for some reason. Not real sure why, but that's there. Now, looking at this pipe, I can tell that there was a piece there, some other sort of piece. Now, just like that unit over there has a P-trap, this unit also needs a P-trap. And you know what? I think I found it. Dun, dun, dun. Look at that. I bet you that's our missing P-trap right there. Well, that may just save me a trip to the hardware store, huh? Not sure how I got all the way over there, but now you might be wondering why I don't just get some PVC glue and glue that on there. And the reasoning is simple, because I want to make sure you can clean this out. Because at some point in time it will clog up. You will have to take it apart and clean it out. And rather than cut it all apart, I'd rather just be able to pull it apart and clean it out real quick. So we should be filling up with water now. There we go. As you can probably hear, the gurgling noise stopped. So for those of you that may not know how P-traps work, it's really simple. You want to trap the water in here because this particular side of the unit is our return air. So our blower is sucking air up through here, through our filters, over here, through the evaporator, into the blower, and then down into the supply side. So that puts this drain on the negative side of the system. So if you don't have water trapped in here, what'll happen is that blower is so powerful, like when we had it just like this, that blower will actually pull air up through the condensate line, so water can't flow out. So that drain pan inside there will actually overflow, and it'll usually go down the return vent and leak wherever, you know, the path of least resistance. Pretty common problem, which we just solved because we were lucky enough to find the missing piece over there on the roof. So I'm guessing maybe they had a preventative maintenance done, somebody cleaned it out, dropped it, kicked it across the roof for some reason, who knows, but that's all set. Now, that doesn't mean I'm going to stop right there. Since I'm already on site and I already have a work order to look at this unit, I'm going to step back, take a look at the bigger picture. So I know already I'm going to need to clean my condensing coils. So we'll get that done, run a hose up here, clean that. I'm going to double check my filters. Looks like we're missing a metal mesh screen. I'll have to put that on the list of things to order. We'll check our filters, check our belts. We'll give this thing a quick rundown. Like I said, big picture diagnosis. Chris Stefanovic, if you're listening, I'll send you a check for using your catchphrase, but it's a good one. What can I say? I mean, you can't go wrong with big picture diagnosis. You gotta step back and look at everything. So let me put this down, open up some panels, run a water hose up here, and see what we're gonna get ourselves into. There we go. Just need to get this cottonwood off here. Definitely not as bad as it could have been. But, like I always say, it'll get worse before it gets better unless we clean it. Alright guys, we're back up and running. Real quick, as I've told you before, kind of smack this coil, get all that water out. Really, I need to start carrying a leaf blower in my truck if I'm going to do more of these micro channels, but kind of tap it just a little bit, try to get that water out. This is a R410 system, and these micro channel coils do a really good job at hanging onto this water after you get done cleaning it. So what'll happen is if it can't get rid of all that water immediately, it could trip on high head. Or the other thing that could happen too is if this is a tube and fin coil and a very, very wet evaporator, or excuse me, a very, very wet condensing coil, then you could underfeed your TXV in your evaporator. But anyways, I digress. Try to get all that water out of there so we're not tripping out on high head pressure here. Alright guys, that does it for today. I know, quick, simple, easy, boring little video, but anyway, hope it gave you guys something to watch while you're sitting at home, possibly in quarantine, possibly sitting on the can somewhere, wherever you are. I hope these last few minutes were as enjoyable for you as they were for me. So with that, I bid adieu, and I will see you on the next one, alright guys? Alright, so, walk-in freezer here. We're at 60 degrees. Those should be spinning. Obviously they're not. I'm not even going to check for power because I assume those are off because of our defrost termination fan delay switch. So let's get up on the roof. Our problem lies up on the roof, I assume. Picture of that. All right, guys. Here's our condensing unit. As you can tell, we got nothing going on. Disconnect is in the on position. Oh, look at this. I'll just take that right off. Nothing running. So we're off on high head pressure. Only got one fan going. Alright, so the sight glass looks clear. So what I'm going to do before I proceed is I'm going to pop this top right here, just so I can get access to the fan that's on the left there. I want to make sure there's no fan cycling switch over there. I don't believe there is, but honestly I can't remember from the last time I've worked on this system. So pop the top, see if there's a fan cycling switch, and we'll go from there. Alright guys, so as you can tell, it is now big floppy sun hat season. So anyway, the far left condensing fan motor is bad. It's seized up. We're gonna have to replace it. No big deal. I verified there is no fan cycling switch on this unit. It operates, or it controls head pressure with a simple headmaster head pressure control, hold back valve, whatever you want to call it. So I'm going to replace the condensing fan motor, clean the condensing coil. It doesn't look bad, but the rule of thumb is, of course, you don't know it's clean until you clean it yourself. So that's what I'm going to do. That seems to be our only issue so far. All the electronics look good. There doesn't appear to be any other issues, but I won't know that until I return airflow, because you can't properly diagnose the system until you have proper airflow. So clean the condensing coil, replace the condensing fan, and then we can go from there. Now, one of the things I originally questioned when I was first getting into the trades are these manual reset high limit switches. You know, in this particular instance, they lost probably $2,000 worth of product because the unit went off on high head pressure and it shut off, because again, that's a manual reset switch. You have to physically push the button to reset it. It doesn't automatically reset. Now, when I was first starting off, I didn't understand why would they do that. You just lost all the product because nobody put in an automatic reset switch in there. Well, if it's not obvious, the reason is because you don't want that compressor to be cycling on and off for who knows how many days. Nobody knows this location was closed. They just decided to come check it a few days ago. So had they have had an automatic reset switch on here, this compressor could have just destroyed itself, resetting, turning on, shutting off on high head again, resetting, coming on, running, turning off on high head until it destroyed itself. So it's kind of a win-lose situation. They won because they didn't destroy the compressor, as far as I can tell, but they lost because they lost like $2,000 worth of product. Granted, their insurance will probably cover, you know, the loss of product, but I don't know. So anyways, that's my story. Let me go grab a condensing fan motor, run a hose up here, and we'll get something accomplished, all right? All right, as you can tell, I got my motors off. I got some foaming agent on there. It's not really foaming up that much, so I'm assuming the coil is not as dirty as I was expecting. So let's see if I can do this one-handed. Turn this on, blast right through there. A little bit of gunk in there. Really not bad though. Alright guys, we are just about ready to power this thing back on and see what happens. I replaced both the condensing fan motors. Originally, the left one was seized up. The right one was spinning, but I did notice when I powered the condenser off, the right side motor stopped pretty abruptly. So rather than run the risk of replacing just one, and in a couple days or a week or 2 weeks maybe, the right side condensing fan motor shuts off and then we have the same situation all over again and they lose all their products. So I just went ahead and replaced both the condensing fan motors. It was approved by the customer. I don't get paid commission on parts, so I'm literally only doing it to prevent any other sorts of breakdowns over the summer. So anyway, both of those are replaced. Condensing coil is nice and clean. Let's power it on, make sure we're going in the right direction. We should be. And we are. Real quick guys, I want to show you. This is the condensing fan motor I like to carry on my truck. Just sort of a universal motor. Hvac, part number S58-998, dual voltage, reversible, all that fun stuff. It's just been a good, reliable motor for me, so I always like to carry two of them on my truck for this very reason. So yeah, let's let this run for a little bit, guys. and we'll check the temperature in our box in just a little bit and see if we're making any progress. We're back up here at the roof. Box temperature dropped about 10-15 degrees already. Suction line, beer can cold. That's all I'm going for. Hot gas line, nice and hot. Now my sight glass is nice and clear on this. Suction line's cool. Hot gas line is hot. Everything looks normal, so in my opinion there's no reason for me to gauge up to it. Now, depending on how the next 45 minutes goes and the temperature rate that we have, then maybe I'll think about it, but right now that box is just so hot. It's probably, when I first started off, it's probably 70, maybe even 80 degrees in that box. The thermometer that's on the wall on the outside of the box was well above 60, so probably 70 or 80 degrees. So it's going to take a little while to actually recover. So right now, with such a high load on this system, there's really no reason for me to check pressures right now. So like I said, sight glass is full, condenser coil is clean, fans are blowing air. I mean, everything's pretty good right now. So we're just going to let it do its thing for the next 45 minutes and see what happens, all right? All right, guys, I'm just wrapping up and getting out here now. Unit's up and running. I watched the box temperature drop from 80 degrees when I first got here down to about 33 degrees when I just left. I would have liked to stuck around and watched the temperature drop down to -10 and watch it pump down, shut off, just to make sure 100% that everything is operational. But I just wasn't able to do that because this location is technically closed. So the manager couldn't stick around for the next, who knows, 2-3 hours before that unit would have reached temperature and shut off. But they're gonna come back tomorrow, double check the temperature, make sure everything's working fine. There's no product in it right now, so it really isn't a big deal at the moment. And like I said, they're gonna come back tomorrow, double check everything, and give us a call if anything funky's going on. But as fast as that thing dropped down from 80 to 33, it looks like everything's good to go. I didn't see anything alarming on it. So anyways, hope you guys liked the video, and hopefully this nice warm weather keeps going so there's a lot more fun stuff to film for you guys, all right? So stick around. We'll see if there's anything cool coming up, all right? We'll see you guys in the next one. Hey, what's up, guys? So today we are on a roof, of course, as you can tell, and we're looking at this guy right here. Older Lennox unit. And apparently what it's doing is tripping the breaker. Watch out for our, for whatever reason, long, weird, extended drain line there. Yeah, it's not sure why they have to run it 9 feet away from the unit, but anyway. So this unit is simply tripping the breaker. About 10 or 15 minutes after they turn it on. If I had to guess, that sounds like it's kicking on maybe first or second, probably second stage if I had to guess. The unit comes on, eventually kicks into second stage, and then the compressor takes out the breaker. So I'm going to assume, before we do anything, just to see if I can predict the problem, I'm going to assume our second stage compressor is tripped out based on what the customer told me. Model serial number. This model number is kind of weird. I'm not real familiar with the LGA 088. I would assume an 84 is a 7-ton, so this is like a 7 1/4 ton or something. Weird. So yeah, first thing, make sure we're off. I know we're off of the breaker downstairs. Just to be extra safe, I'm going to turn that off right there. And we're just going to visually inspect everything. Alright, so we do have 2-stage cooling. This is kind of popped out for some reason. Right off the bat, I don't see any obvious signs of arcing or melted wires or any of the telltale signs of something tripping a breaker. Back over here. Just checking my wires. Making sure we don't have anything rubbing through. That belt's pretty loose and there's no spare. We'll have to adjust the tension on that belt. Yeah, this isn't hanging. Everything's secured nice and tight. So, I think what I'll do is I'll just pull the covers off, or pull the terminal blocks off my compressors, check them to ground real quick. There's our circuit number 2. I'm going to check that one first. I love how the wind is just shoving this door right in my face this entire time. I'm not a big fan of the wind. You know that, guys? I'm not a fan of the wind at all. Alright, it's not melted. Nothing crazy. Let's see if I can do this one-handed here. How am I going to do this? There we go. Alright. Well, it's not shorted to ground anyway. This one is, though. So our stage 1 compressor shorted to ground, all 3 terminals. I was betting on this one. Interesting. Alright, I got the breaker flipped back on. I'm going to turn the disconnect on. I'm just going to take a quick amp draw of my number 2 compressor. Number 1 is disconnected. I also took the 24 volts off the contactor, taped it up so it's nice and safe out of the way. You can hear our blower. You can hear the belt flopping around. We'll have to tighten that up in a little bit here. I just want to make sure my number 2 compressor is operational before I do anything else crazy. Sort of like a big picture diagnosis, I guess you might say. I just noticed we are flashing a couple codes here, 91, and it was flashing 75. 75 is outdoor RT17 sensor problem and outdoor enthalpy sensor. Interesting. Let's take a look at that. The compressor doesn't sound real good at all. And right now I'm just bumping the contactor. 5, 9, 10, 10. 12. Amp draw is just climbing. Discharge line is warm. Suction line is cool. Just the sound of that compressor kind of worries me. So real quick, let's go over here. We'll check our outdoor temperature sensors right back here. Pop this out of its little bracket. There's our little outdoor temperature sensor, RT17. And I'm just looking for wiring damage. Normally, since these go up into the coil, they're damaged. Yeah, see right there. I don't know if you can see this. Let's bust this open a little bit, but it looks like right there. Focus in. So right there we have some broken wires. So I don't see any other problem. The sensor looks good. The wiring all in through here, around the side, and the other side of the condenser looks good, and all the way through the cabinet, that all looks good. So I'm just going to trim those back, wire nut them, put it back in there, and see if that's successful. Normally it is. It's a common problem on these Lennox. And the other thing we have here is our solid state enthalpy sensor right here. And what I noticed as I was just messing with it, this thing popped out. Right there, this thing popped right out of it. So I'm no scientist, but I believe those spade ends that's attached to this terminal, those spades are supposed to remain inside of this solid state relay, or this solid state enthalpy sensor rather. So I'm just gonna have to get a new one of those. Simple. Got the sensor all fixed up, wire nuts are in, taped up. I'm gonna point these up just so they don't start collecting moisture. And we'll just tuck them back up in there like so. Yada yada yada. Tuck this little guy right back in there. Not sure if you can see that. Right. So I might have to throw a zip tie on there just to keep these wires nice and tight. So in the meantime, guys, I need to get two hands in on this so I can kind of tuck this wire up there and zip tie it nice and tight and secure. Drop this top back down, secure it all up, and then we'll see what happens after that. So I got the tension back on my belt here. Not bad. About a 1/2 inch deflection. Rule of thumb, you know. And as I was doing so, I noticed my pulleys are out of alignment. Now this drive pulley back there, not sure how well you can see that because it's so bright out here. It makes the inside of the machine really, really dark. Anyway, my drive pulley back there is about 1/2 inch-ish out of alignment with my motor pulley, or my blower pulley, I guess you'd call it. This is my drive pulley. That's my blower pulley. Anyway, the blower pulley is about a 1/2 inch out of alignment of my drive pulley right here. On top of that, both pulleys are pretty worn. If you can get your finger back inside that little lip that's on the pulley there, it's just got a nice deep bevel to it. And this one's even worse. So the way the blower is set up, there's no way I'm going to be able to move that blower pulley. And I mean, it looks rusted. The keyway's maybe not even down all the way. I'm not sure what's going on with that keyway, but I'm going to have to lube that shaft up real good, probably sand it off, and then I'm gonna have to put a pulley puller on it, I'm guessing, just to slide that over a little bit. But I can't put a pulley puller on there in the position it's in right now. So what I'm gonna do is quote new belts, new pulleys, and then when I come back, I'm gonna have to remove the motor and this motor mount right here, and then I can disengage the blower, the entire blower assembly, and then I can just slide it right out. I mean, you're talking probably 2-3 hours of work to take everything apart, adjust the pulley, and then you know, slide it all back in together. So what I'll probably do is when I pull that blower out, I'm gonna take that blower pulley, and when I put the new one on, rather, I'm gonna clean it up nice and smooth, obviously. And when I put it on, I'm going to leave it out just a little bit to the right side here. And this way, when I slide it back in, it'll be easier. I can just tap it over with a hammer or something to line it up properly, rather than if I tapped it in or put it in too close to the blower and then I had to try to, you know, move it off to the right and try to pull it off there. It might not want to go. So that's what I'm going to try to do anyway. I'm all wrapped up here. So let's recap. This guy right here, stage 1 compressor, shorted out. Stage 2 compressor is working. It's louder than normal. It's louder than I like. The amp draw is within spec. It's cooling. I had a supply temp of 58 degrees with just the stage 2 compressor going. So I'm going to leave that alone for now and just explain to the customer that it's making a little bit of a noise I don't like. So we're going to replace our blower pulley, our drive pulley, pull up the belts, contactors, dryers, the whole 9 yards. The other thing I'm going to do too, since I have the blower out if they approve this quote, I'm also going to clean the blower assembly, and I'm also going to split this condensing coil. So I'm looking at least a full day of work here. Oh yeah, don't forget, we're going to do this outdoor enthalpy sensor. That's right inside of there. So yeah, outdoor enthalpy sensor, compressor, filter dryer, contactor, belts, pulleys, clean the blower wheel, clean the condensing coil. So yeah, it's going to be a fun day. So this is going to be part 1. I'll see you guys on part 2, all right? Take it easy. Hey, what's up, YouTube? So here's what we got going on today. I got a walk-in freezer. It's sitting steady at about 30-35 degrees. I already took a look at it. The evaporator is a solid block of ice. I got to run down there, check something real quick, so I'll give you a quick little peek at that. And then we're going to come back up on the roof and start the troubleshooting process. All right? So, follow me. All right, just above 30 degrees. There is our very frozen evaporator. You probably can't see it, but if you look up in through the fan blades, it's solid ice just through and through. First thing I'm going to do, since it's already frozen, and I know my defrost circuit, my defrost high limit switch and my fan delay defrost termination switch are most likely closed, I'm going to get upstairs and just verify my heaters have an amp draw first. So let's go back upstairs. I was up here originally, I did check our time, so it does look like the clock is rotating on its own. So the first thing I'm going to do, just push a bunch of buttons down so we got a really, really long defrost. Then we're going to put it in defrost. Take a quick amp draw. There we are. Got about 12.5 amps. So our heaters are good. And the unit should start pumping down. Should start pumping down. Also, while we wait for this thing to pump down, there's a lot of ice on that evaporator coil, and the way those what you call them, slim evaporator coils, the way they're set up, they're kind of hard to clean once you pull that cover off. So I'm going to try to let it defrost as much as it can using the heaters. So I'm going to pull my defrost termination switch off of the timer, and this way it should stay in defrost either until my high limit switch trips or we run out of time. That's the idea. So I'm just going to pull that out real quick, tape it off, and go from there. The unit has been in defrost for 2 or 3 minutes now, and it has not pumped down yet. I hope you can see this. So right now I'm all hooked up, high side, low side. I found a little 90-degree elbow in my bag, so I threw it on there. Now this compressor has been attempting to pump down for the last 3 or 4-ish minutes. And it's actually going up a little tiny bit. It was at about 9.8, and then it got up to 10.4. Now we're at 11.6 on my low side. My pump down switch. Let's see, high event, low event. It's a mechanical switch, so you can't always believe the numbers. I'm gonna guess it's roughly it's set for about 12 maybe. I prefer to set them a little lower, about 5 psi rather. So this isn't pumping down at all. It's coming close, but it just can't do it. So chances are our compressor is just bad. It's inefficient. And so to rule out that my liquid line solenoid downstairs is actually closed, what I did was just close down my, I'm just going to call it a king valve right here. I closed this down and it pumped down right down to 4.8. So now, rather than having a compressor issue like I thought I had a few minutes ago, I'm leaning more towards we have a liquid line solenoid issue, right? Which is good though, because, I mean, it's not good, but it was good that I tried that because I was able to actually tell that we shut off at 5 psi, which is right about what I want. So now we have to go figure out why my liquid line solenoid isn't closing. All right, guys, we're squeezed into this walk-in box. I'm at the far right corner of the evaporator coil. There's our thermostat. It is calling for cooling, however, it doesn't have the power. I got my liquid line solenoid pulled off over here. You'll notice some of our wiring at some point in time got too close to our heaters, so we got to fix some of that. But I just want to snap this and real quick see what happens. Yeah. Now that's, even though I got a good distinctive snap, that's not to say it could be leaking by a little bit. I just haven't ever replaced one of those because they're bad. I rarely ever find them bad. I think, honestly, maybe in my career I've done one. Replaced one liquid line solenoid because it was bad. I don't see them that often. So what I'm going to do is I'm going to put the solenoid back on. I'm going to go upstairs and open that liquid line king valve and just see what happens. So I have the king valve upstairs open. I have the solenoid physically off the valve body. Hopefully you can hear that. But it's actually making noise as it's feeding through there. Yeah, so it's not closing down at all. That's not cool. What I found out, let's see, it's gonna be kind of hard to show you, but get over here, real nice and close like. If you can see that right there in the back of that solenoid valve, there's an arrow and it's going the wrong way. Now I did find out this unit was serviced recently and somebody had changed the liquid line solenoid valve because the other one was plugged up. And they put that one in the wrong direction. So that's why it can't close. I'm half tempted to see if I can pull it out and turn it around, but I don't know. I just don't like to do that. I run the risk of ruining it. So I'm not sure. I'll have to think about this here. Go over some options. First, I got to get all the ice off here. That's going to take a while in itself before I can even get access to the piping here. Alright guys and gals, so it is the next day. We're here to replace this liquid line solenoid valve. And if you don't remember from, I don't know, 2 minutes ago when that last clip was, or yesterday, what I'm going to do is I'm going to pump the unit down. I'm going to close off the suction line service valve and the liquid line service valve at my condensing unit. Then I'm going to go downstairs, swap out that liquid line solenoid valve, pull a vacuum on the line set and the evaporator, and then we're going to simply release the charge. Alright guys, I'm going to have to yell over this fan right now. Just wanted to show you a quick little trick that I just sort of figured out. Since I forgot my large set of Allen keys downstairs for my suction side, I realized if you take your fancy little Lennox multi screwdriver, it fits right in there. Might have to get a wrench on there though, but I'm gonna pump it down that way. Anyway, first let's start with our liquid side. Let's get this thing pumped down. It's been running all night long, non-stop. Thermostat's been satisfied a long time ago. Liquid line solenoid was de-energized, but of course can't fully seat. Now my liquid line is closed. Check out our suction side if you can see that. Should start pumping down here. Should shut off right about 5. And then what I'll do is I'll close my suction side. All right, now we're pumped down and off. Let's see if I can do this one-handed. Nope. Holy garbage cans, Batman. All right, so our evaporator and the line set going down to the evaporator are mostly blocked off from the condensing unit. Now these valves, they're not 100% leak proof. There will be a little bit of refrigerant leaking by. Probably really won't even notice it. All right guys, it's really hard for me to show you any of this process because I'm literally right up against a wall here trying to work over top of my head. Here's our old valve. I got it out. There's the new one. I'm gonna mount it outside of the evaporator box. So it's just easier for me to do it that way. Let's see right there. And this little port right here is where I'm gonna pull a vacuum on this line set. So I'll run some new wires because those are melted. Yeah. All right, let's get this show on the road. All right, here is the final product. There's our solenoid. Just routed the wires through there. Bingo bango, right over here to our thermostat. So, only thing left to do is open the valves up on the roof and let this thing run for a little while. Well, here's the moment of truth. I'm gonna open up my liquid line. I already got my suction side opened up, but we're still off on low pressure because obviously my liquid line is closed. So, if everything is fully operational downstairs, I'm gonna open this up. We should pressurize and should kick on and run. All right. Running. That's good. Pressure's rising. All right. Now we just wait for that temperature downstairs to drop. Holy crap, it's ungodly bright out here, so I can't see you, so I hope you can see me. So anyway, let's do a quick recap here. When a previous technician installed that liquid line solenoid valve, like I said, like I showed you, he installed it backwards. Now, I'm not trying to call anybody out on this. I've brazed them in backwards. That's how I learned you can braze them in backwards. Before that, I never knew. Same with filter dryers. Anyway, the point is, just make sure you're taking your time. Slow down, pay attention. It's the little things that count. Like my buddy Chris Stevens from HVACR videos always says, you got to look at the little picture diagnosis, all right? So anyway, our box is down to temperature. I'm just going to tidy up, throw some screws on this thing, then we're going to get out of here, all right? Shoot, you know, I almost forgot something. There, now we're all set. Anyways, if any of you guys out there want some of these Curious HVAC Guy stickers, feel free to shoot me an email with your address. I'll send some out to you. I'll put the address at the bottom of the screen here. Thanks for watching, guys. Hey, what's up, YouTube? So, real quick, I just got done filming a little bit of stuff on this Baxter oven. It's a giant carousel style bread oven. I mean, the thing's got to be 7-8 foot tall. It's ginormous. You can literally climb inside, as you'll see. You can climb inside, stand up in it, work inside of it, whatever you got to do. I just wanted to give a quick disclaimer on these ovens. I am not an expert. There's a lot I don't know on these ovens, so forgive me. The footage is somewhat choppy, but I so rarely get to work on these, let alone film them while I'm working on them. I figure whatever film I can get, whatever footage I can get, whatever I can show anybody on these would be beneficial to somebody. At the very least, if you're bored, you want something to watch, you want to see what a giant oven looks like, you want to see me crawl out of a giant oven, almost like this oven has given birth to a technician, that's what you're going to see. Forgive me for my lack of knowledge on these, but I just wanted to give you guys something cool to look at today. So enjoy it for what it's worth, whatever it's worth to you, enjoy it. If you have any questions, shoot me an email. Email will be down below here, all right? Have a good day, guys. We'll talk to you soon, all right? All right, guys. So today we are looking at a giant bread oven at a well-known sub shop. The problem is it's flaming out or purging every once in a while, and it'll stop our carousel rack on the inside. So the first thing we're going to do is just go through, double check all our connections, double check our ignition module, our chain tension, double check a few other connections that can possibly lead to this particular issue. First thing we're going to do, right above you here, Gary, there's a micro switch, or excuse me, there's an air port, not the kind with planes in it, but an actual little port where air is pulled in and it proves that there's actually air flowing through here. We're going to double check that in a second here, once I get this mile-long screw out. There we go. First thing we always do, right up there, that port right there is usually plugged with dust, but today it's not. It's nice and clean, so they're doing a good job with their maintenance here. Our filters look decent, so that's not our cause. And whenever I'm working on something like this, always check your connections. These ovens get very hot, they vibrate a little bit. There's always a chance you have a loose connection in here somewhere, but these aren't too bad at all. Chain tension isn't bad. Another thing on these, some places this happens to more than others. They sometimes drop bread pans in here. Now this location would never do that because they're much better than the other locations. But you want to make sure there's nothing blocking this carousel from moving around. Doesn't look like there's anything obstructing it, so we're good there. Just a few minutes, we're going to open up that trap door and climb inside and look at our actual spark assembly. There's our two gas ports, of course our gas valve down there. Those grates right there, make sure those are clean. If not, you're not going to get a proper flame, and it will flame out. So, you want to pop that open, Gary? Hopefully there's no bodies in there like last time. Alright. What I've seen before too, this, I forget exactly what it's called, but this brick surface here that just helps even out the flames. Sometimes those will get misaligned, it'll jam them up on one of these carousels. Oh yeah, look at that. Nice and dirty, that's going to be fun to climb into. Alright guys, let me put this camera down, climb inside, and we'll get started. Alright guys, so I'm about to climb in here, but before we can do that, I have to line up that bread oven because my giant fat body won't fit underneath there. So we are going to turn our motor. There's a hand crank right there that the Amish use. But I don't know if my impactor is strong enough to do this. There we go. Let's go nice and slow. Let's see it slowly moving. My battery's gonna die doing this. Right about there. That's what I want. Now, we can begin our journey of climbing inside. Let's take a quick look around. We are now inside this oven. Grab my flashlight here. So, what I'm doing in here is I need to inspect my pilot assembly, make sure my flame rod is clean, make sure the sparker's lined up, all that fun stuff. So, that's what we're doing right now. And what I am doing, I lined up this bread tray, this carousel, so that I am just laying on top of it. Because if you don't, you're going to have a hard time getting to this pilot assembly. There you go. Like that. I bet they squeal a little bit when they start up. I bet they squeal a little bit when they start up.
Oh my gosh. Is there zerk fittings on them?
I believe so, yeah. Alright guys, there is our pilot assembly. Keep in mind when you pull these out, be wary of this pilot tube, because if there's a lot of tension on that pilot tube, you'll break it right off. So all I'm gonna do is I'm just gonna clean this flame rod right here. I'm doing all this before I fire it up and verify symptoms, because I don't want it to be hot, because once it's hot, you're not gonna want to be inside this oven. So let's get after it. Now it's hard to see this connection. It's a push-on connection. Make sure it's tight. Alright, connection's nice and tight.
Thursday. I was able to bake on Thursday, but
Still the best way to clean a flame rod. Oh, very nice. That's much better.
Don't look it in the way.
I'll take that one out of here. Alright guys, these are my legs. I am still inside this oven here. I wanted to point this out real quick. This is the main bearing that holds this massive carousel in place. If you'll notice, it's cracked and badly worn. Let's see if we can get up around the sides here. Yeah, there we go. There's a little bit better view of it. So that'll need to be changed out. That itself is not an easy task. So we'll let the facility manager know about that and see what he wants to do with it. Alright guys, here's a better view of this bearing and its egged out shaft or egged out bearing. Yeah, it's not supposed to have that big a gap in there. So that's something that needs to be addressed much sooner than much later. Another thing we're going to check is the brick alignment down there. It's not terrible. Those bricks are just used to help dissipate the heat and even it out a little bit. Yeah, right down there. Not bad. It doesn't look like they're catching on anything. Usually if they are, obviously you'll see like broken pieces of brick and whatnot, but that's not terrible. So I think we're going to make our way out of here and fire it up in just a minute. There's our exit. Alright guys, I'm out of the oven. We're going to fire it up with the door open. To do so, you have to bypass this little switch. It's a little micro switch. This thing just goes in there, pushes a little lever, and closes that micro switch. So, jam a piece of cardboard in there, put some tape on it, you're good to go. We fire it up, and we have a 6-minute delay as it goes through, checks all of its probes, its pressure sensors, its safety things, everything like that. So, we're going to stand here for about 6 minutes and just watch it. Keep an eye on that oil stain down there though. Hopefully our motor's not going bad. You can notice the right side of that carousel is sagging a little bit as it comes around. Look at it in comparison to the bricks. It's definitely got a sag to it. Wow. That sounds really bad. So what we're looking at right now is a clicking or ticking noise that we found while I was running. The unit shut off a few random times. Really not sure why it shut off, but we suspect that it's one of these relays in here clicking or something. So I don't know. I don't see anything out of the ordinary. Like our contacts points aren't bad. Say we fire it up and see if we can see which one is clicking. Quick update here. Still haven't figured out the ticking noise. However, our oven still randomly stops. So we checked our brushes inside the motor. Those appear to be fine. I'm waiting for it to kick on so I can do an amp draw and compare that to our 2.5 amps. I have a feeling that bearing that we saw inside there is dragging and our motor is just over torquing. And our motor control is shutting it off. So, we'll wait and see. It's not bad. Alright guys, we've been running for about 15 minutes. Still pulling about 1.15 amps on our motor. Our ticking noise has dissipated. I'm guessing that maybe it had to do something with my brushes that I cleaned off inside the motor. I have the temperature turned down right now, down to about 150, so there's no flame, but we're just waiting for this thing to stop and listening to this horrible howling noise. My fear is that bearing is going to completely give way and that carousel is just going to drop. once that happens, then they're gonna be screwed, obviously. Awesome. Just like an old haunted mansion. Alright, looks like we're all set here. 3, 4, good to go. Hey, what's up YouTube? So, I am on site at a restaurant here, and they're complaining that their walk-in freezer is getting a little warm. And apparently, a week or two ago, another company was out here looking at it, and for whatever reason, they didn't like that company, so now I'm here. So, let's mask up and go see what's going on in there, alright? Alright, first thing I notice is door doesn't want to close on its own. Have to add a new hydraulic door closer to our quote. So, let's see what we got going on here. Definitely feels like this has been off for a while. Peekaboo. That's high quality wall panels right there, bud. Set to 0. What I'm going to do first is just see if we have power at that thermostat. Go from there. Chances are our issue is up on the roof. Our defrost heaters are on. I can feel them. So maybe we're just stuck in defrost. Manager said it's been warm pretty much all day, so. Look at that. Alright guys, so before I go upstairs, let's take a look at a couple things. It's 52 degrees inside this box right now. My defrost heaters are still on. Let's check around up there. I'm going to double check the other side, but I didn't see anything on the other side. There's no defrost termination switch. There's no high limit switch. There's nothing that cuts these heaters off. Besides the defrost timer, of course. But there's no early termination switch. Nothing. It's crazy. Let's check this thing out. See right there? It says defrost termination fan delay switch. Note number 4. Interesting. So the schematic shows one, or it had one at one point in time, but apparently no longer has one. So I'm guessing that whoever did whatever to this system in the past has taken that out. And now they just run defrost based solely on time, and it's probably stuck in defrost, and there's nothing to kick it out early, which is crazy. That's crazy talk, right? Alright, let's wrap this up and head up to the roof and see what we got going on up there. Alright guys, here's our condensing unit. It's a Heatcraft. Got no information on there. This thing's got to be original to the building, judging by its condition. I'm guessing at least 30 years old, 25, 30 years old. There's our defrost clock. It does appear to still be in defrost 4 times a day at 30 minutes. If you'll notice over here, and we do have a wire hooked up to our X terminal, which would indicate that we have some sort of early termination switch. But I didn't see anything like that downstairs. So I have no idea what that blue wire goes to. All right, real quick, guys. Here's our blue wire coming off of that X terminal on our defrost clock. And it just goes to this terminal, this X terminal right there. There's nothing connected to it, so we indeed do not have any sort of early termination for this defrost. So I'm gonna have to write that up and probably quote or talk to the manufacturer at least, and we'll get one put in there. Let's just give this a spin. I'm going to set it right there. We're going to watch it for a little while. Just to make sure that defrost clock rotates on its own. But even if it does rotate on its own, I think I'm still going to change it out because I have no idea how long it's been in defrost and if that was our issue. So let's keep moving on and see what else we can find wrong with this thing. Alright guys, if you'll notice, our left side condensing fan motor is running, the right side is not. Obviously that's bad. I don't believe this is on a fan cycle switch, plus it's 80 degrees outside, so there'd be no reason to cycle this fan on and off. So we're going to be replacing that condensing fan motor. The sight glass looks clear, that's good. Just shut off on what I believe to be high head pressure. All right. Let's kick that disconnect off. I'm gonna run downstairs, grab a condensing fan motor, and I'm also going to grab a defrost clock. Well, I got good weather over there, really bad weather over there, and I'm not sure which way it's moving, so I'm gonna get this fan changed out as fast as possible. So you might not be able to see me change this fan out because I might just throw my camera right on the ground and do this as fast as I can. So I apologize in advance. But trust me, it's boring. It's 4 screws. I'm gonna pop that off. I'm gonna put in my favorite Hvac motor that I keep in my truck. And I got the same old mechanical timer that I'm gonna throw in there. So let's get after it. All right, guys. I had to come down here to the other side of the roof where it's a little quieter. So, walk-in freezer is up and running. I replaced the defrost clock and the right side condensing fan motor. Now, when I got the service call, I got what we call an NTE, not to exceed amount of $500, meaning I cannot spend more than $500 on the service call without approval. And right now it's after hours, so the people that approve that are not at their cubicles. So I'm sort of rushing it, doing as thorough of a job as I can in the amount of time that I'm allocated, right? So anyway, we're up and running. I'm going to quote to come back, put a defrost termination fan delay switch in there, like you should have. And then when I have that extra time, I'm going to go through it a little bit more, just to make sure all the bugs are worked out. The left side condensing fan motor, normally I like to replace those in pairs because they're usually about the same age. You know, they go through the same amount of wear and tear. That left side condensing fan motor though, spun really freely, capacitor was fine. I really saw no issue with it. I mean, really what they need to do is just upgrade this entire system. Tear that walk-in box out, put in better panels, you know. Are they gonna do that? No, not ever. Maybe if the building burns down, they'll think about it, but not ever. So anyway, I'm gonna go downstairs, check our box temperature, and then we gotta rush and get out of here because I don't want to work for free, and that's what's gonna happen here in a little bit. So, all right, guys, stick around. We'll see what happens on the next visit here. All right. Thanks for watching. Are you tired of never having the correct capacitor on your truck? Do you have one of these universal capacitors but don't want to use it because it looks like it's from the future and it scares you? Well, if so, you came to the right place. So today, we're going to quickly talk about how to wire capacitors in parallel and in series. So we can essentially make a bigger capacitor in parallel, or we can wire them in series and make a smaller capacitor. Let's start playing with some capacitors safely. All right, guys, so first let's start by wiring capacitors in parallel to make larger capacitors. For demonstrational purposes, we're just going to use the easy ones. We got 5, 10, a 15, and a 20. So let's say you're on a job and you need a 15 microfarad capacitor, but you don't have one. All you have is, let's say, a 10, a 20, and a 5. Well, you can take your 10 and your 5, simply wire them in parallel, and you can make a 15. Those are now wired in parallel. Now let's run a imaginary wire off to our motor or our compressor or whatever it is we need to run. Now let's test it and see if we do indeed have 15 microfarads. And we do, 14.94. All right. Now, let's say we need a 40 microfarad capacitor. And all we have at our disposal is a 15, a 20, a 5, and a 10. Well, we can use our 20, 15, and, oh, wrong one. 20, 15, and a 5, and we can make a 40 microfarad capacitor. So, let's wire these guys in parallel. All right, so right here, all these capacitors wired in parallel, we should indeed have a homemade 40 microfarad capacitor. And we do, 39.79 microfarads. Now, having all these capacitors inside, let's say, a little tiny condensing unit or the blower housing of a furnace might be kind of difficult. But again, this is just for emergency purposes. You could do something like this to get them by until the following day. Now, let's say we needed a 50. Let's just wire this 10 in parallel here. We'll just add the 10 on the end here. Now, this may not give you enough gigawatts to get you back to 1985, but it may give you just enough power to get whatever it is you need running, up and running for the night. There we do. We have 50 microfarads, 49.6. So that, guys, essentially is how you can wire capacitors in parallel to make a larger capacitor. All right, guys. So let's get into how to wire capacitors in series to essentially make a smaller capacitor. Now, the mathematical formula for this is simply capacitor number 1 times capacitor number 2 divided by capacitor number 1 plus capacitor number 2. Pretty simple, but in my opinion, you're not going to use this nearly as much as you would wiring capacitors in parallel. Very rarely would you need to make some sort of weird small size capacitor. So we'll go through a couple little examples here. The first one, we'll take our 5. So let's say we only have we only have two 5 microfarad capacitors on our truck, and for whatever reason, we need a 2.5. So let's go 5 times 5, which is, of course, 25. Then we'll do 5 plus 5, which, according to my calculations, is 10. And then we divide that, we get 2.5. So by taking these two capacitors, wiring them in series, we should get a 2.5 microfarad capacitor. Right there, this is our series. Now let's see if this is correct. And we do, 2.5. So in whatever emergency that we had where we needed a 2.5 microfarad capacitor, but we only had 5s, and we didn't want to overload the motor by putting 5s in there, we could simply wire these in series and make a 2.5. All right, let's move on to another example here. Let's say we need a 5 microfarad capacitor, and all we have on our truck are two 10 microfarad capacitors. First, let's do the quick little math here. 10 times 10 is 100. 10 plus 10, I'm pretty sure is still 20. So you guys can do the math. If I can write here. Comes out to 5. So let's test out that theory. Wire this one in series with this one. Boom. Boom. We are now in series. Two 10 microfarad capacitors in series should essentially give us a 5 microfarad capacitor. And we do, 5.01 microfarads. Now, let's say for whatever reason we need a 3.75 microfarad capacitor. We'll take our 15, these 10s out of the way, and we'll take our 5. Wire in series. Real simple. Put one here. Put it right there on that one. How about that? There. Now we are in series. We have a 15 and a 5 wired in series. Now let's try it out. We should have 3.75. And we do. 3.72 to be exact. All right, guys. That does it for today's video. Hope you enjoy it. Hope you got something out of it. I know I did. It's been fun, but I'm going to get out of here, all right, guys? So I will see you on the next one. If you do like this video, share it with some friends, all right? We'll see you around.